Hello there, and welcome to Joe's Computer Museum. My name is Joe Strohsnyder of Joe's Computer Museum. And we're here tonight to have some fun fixing some old computers, very specifically with my friend Will here from CayMac Vintage and his Apple III Plus that he is fixing up for somebody. Before we get started again, thanks for everybody for stopping by. Let's throw out some names here. We got Retro Techie for saying JCM-1.com. Thank you, Retro Techie. We got Flintlock, Acid Rain, Eric's Edge, Vintage Tech Guy, Frank S. Francois is here, One Bit Fever Dreams, Thomas Armstrong, Jake Janoski is here, and probably some other people. Biggie John's here, and possibly some other people. So thank you all for stopping by tonight. Remember, if you want to support my museum, the cool content that I do, go to jcm-1.com and buy a Blue Scuzzy or something, or go to my Patreon, Joe's Computer Museum Patreon, for as little as $1 a month. You can hang out with me in Discord, and you can get things like stickers or be part of the behind-the-scenes planning of my next episode, which a lot of my patrons were on. So lots of cool stuff there. But enough about me and my silliness. Let's talk about Will for a bit, because this is all about Will and Will's Apple III. So say hi, Will. Tell everybody who you are, how they can find you, and what the heck we're doing tonight.
Hello, everyone. Welcome. Thank you for joining. As actually Joe said, we're here working on an Apple III Plus. Actually, this belongs to one person that's actually watching and in the channel. Where is he? Jake. Jake is in here. It belongs to him. So
Yay!
He wants to see how we fix this board for him. I've done quite a few other boards for him actually already. Anyway, I do not have Patreon and Facebook and Twitter and all this other stuff. So
old, you're old.
No, it's just I do have it personal, but it just takes up so much of my time.
Yeah, it's a huge
and so I can be found here on my channel. I can be reached by email, which is the same, which is actually CayMac Vintage. And it is at actually Gmail. So those are the two ways to find me.
Cool.
I do quite a bit of shows. Do have quite a few on my channel.
You said doo-doo.
I am waiting for my cargo to actually arrive. I've got about 9 actually computers coming in from actually Florida when I was up there. I've got an Apple IIc Plus coming. I've got another one actually 28 coming. I have an actually portable coming, and the portable is in bad shape, so it's going to need a lot of work. In March, I'm hoping to be working on an actually Lisa. So that would be something interesting. But
cool.
I think that one there, the boards are pretty damaged. I may have to do an actually transfer.
Oh wow!
But the good thing is that there are boards made for it, so I actually ordered those actually today already. Anyway, but yeah, we're here to work on this Apple III Plus.
Mm-hmm. And Will reached out to me. He's like, Joe, you did Apple III repair stuff on a video once. You're an expert. Help me. And I'm like, cowering fear. I'm like, okay, maybe we'll figure it out.
It's gonna be fun. I see actually Flint is here too watching. He is from actually England watching. So for him it is very late over there.
Midnight or so.
Yeah, and he's watching. So thank you for watching, Flint.
Cool.
And then Retro Tech saying I can be the next James Bond. Yeah, right. I don't want that job. No, thank you. So, but yeah, anyway, so that's what we're here for to do, is to work on this machine, so y'all can see what it's like. Here it is.
We'll make you big so people can see what we're doing here.
It does have the 5-volt memory card on it. This is not a 12-volt one. The 12-volt one would have a bunch of 32K chips here.
Mm-hmm.
And this one doesn't. My other Apple, my normal Apple III, that has a lot of the actually 32K chips on it, and it also has 8 of them that I had to modify.
Oh wow! Oh, so, you've got to do the piggyback to make the 4132s out of 41.
Yeah, I did that, but oh shoot, where did I put them? it's funny you say that because um, Jake, that's in the channel, and I are developing a couple things. Where did I put them? Anyway, we've made some boards that you can just put sockets on and header, and then you just pop in the chips, and then you just pop it in. That's it.
Ooh,
You don't have to join them together.
cool.
The prototype one was not too good, so we've had to go to. I just ordered them today. I just ordered some actually new ones. Instead of them being side by side, they are gonna be lengthwise that they will fit
Oh,
in
okay.
better. But yeah, so I do have that coming from an actually PCB manufacturer.
Cool
Um,
beans. That's going to be really helpful for those 12-volt boards.
yes, and we've made actually two of them. We've made a version that works with the 4116 chip and one that works with the 4164.
Cool. Rock
So
on.
so both of them will they both look actually the same, and they will go in lengthways, and you just put on the socket and the header, and you just put in your chip and pop it in. So no more piggybacking.
Let's make it easy for folks
Yeah.
because the Apple III is awful. Wait, no,
Oh,
the Apple III is great. It's great. We love the Apple III. Let's fix it.
well, here we go. Let's see what we can do with it. The board is on right now, and you can
Yep.
see from the screen what it's giving me.
So,
And so I'm not getting a beep or anything, so it's just giving me
gotcha.
that.
So, step one, or the first thing I would say is, at the very least, about 40. I'm sorry, about 75% of the board is just fine, and we
Hmm.
can tell this because the Apple III is very similar to the Apple II in that its video generation is the majority of the machine. Um,
Hmm.
So because we have a steady raster that's not flip-flopping all over the place, and we got a clear bit pattern on the screen repeating with those squares, that means to me the entire video circuit is fine. We can ignore
Hmm.
all of that. That also means that the timing circuit is fine. If the timing was off, that'd be going all over like that and
Well, I
being
mean,
a mess.
when I do turn it on at first, and I don't know if this is the connector or what. I mean, you asked me about this earlier before we went live. Um, well, see, now it's not doing it, but when
Yeah,
it
I think
cools
that's
down,
just the connector. Those
uh,
connectors are just absolute crap.
it is a bit loose. I may have to put a solder ball on that just to hold it.
Yeah. It's usually what happens is you lose the outer ground and it just doesn't it doesn't do the thing.
Yeah, it is not spinning. It's not turning, but it does seem a little loose. Yeah.
Yeah, that's totally typical of those jacks. Hmm. Yep, see, you're touching it, it's going wacky. That's just the jack. As long
Yeah.
as you can get the jack solid so we can do some diagnostics, we'll be fine.
Okay. Well, it is solid there. Now, what I have done to this board, okay, when I did get it, it was very dirty. It had, from what Jake told me, it had actually rats living in the case and everything, and it was pretty bad and nasty.
Oh, that doesn't
Um,
happen to any Apple IIIs ever. What are you talking about? Happened to mine.
yeah.
So yeah.
Um,
Okay.
so I did clean it well. I did actually change the capacitors. They're all changed.
That's good.
Then the only other thing that was missing was over here. It was missing this one actually capacitor 22,
Hmm.
and I looked at the schematics and I found the value and I put it back.
Okay. Is that that's probably just a standard decoupling capacitor, like a zero point 0.1 microfarad or something like that?
Yeah, it wasn't much. I don't remember what page it was on, but
It would honestly probably run without that in there, but that's okay. It's good that we got that replaced.
yeah. So that was the only thing that I found that was not correct. Everything else,
Okay.
I actually examined this board with a microscope and went through everything. I basically popped out just about every single chip. I have actually deoxed all the sockets. Whatever chips look kind of bad, I did swap them out.
Okay. Did
Um,
you replace any really crusty, nasty sockets?
I replaced quite a few for these PAL Gal specialized
Okay.
chips up here. Now these here get very hot. I mean,
That's normal. Those pals and gals
not
get
hot
hot.
hot that I can't put my hand on it, but I
Yeah.
mean right now my hand is getting pretty warm.
Yep.
Okay,
Tech Cowboy is asking what the difference between a 3 and a 3 Plus is. It's mainly the board design. The 3 Plus was a redesign of the 3 after all of the heat and reliability issues of the original 3. It's a relayout of the board. How they did it exactly, I don't know if they went up to a multi-layer board instead of a 2-layer board with those weird bus bars, but basically, electrically, it's the same thing. It's just more reliable in theory. But, I mean, theory is just blown out the window tonight, as we can see by the garbage on Will's screen. So I think what we need, based on what we're seeing here, we've got stable raster, we've got good video. That's telling me effectively the machine's just not running code. So we need to kind of work our way through that. Our first step there is to start looking at all of the pins on the CPU and just see if there's anything that doesn't make sense. First with reset. Is reset high or low? I believe that's pin 40 or 37. I don't remember exactly.
The reset on this one.
Reset's pin 40. It's going to be the that one. Yep.
It is high.
It is high, so that's not.
I mean, you can see the scope. That's why I mean, I tell you, I love the small scope. It was the best $60 that I ever spent.
I agree. Except the $60 you spent at JCM dash. Oh, sorry. Moving on. Pin 37. We should be getting like a 2 megahertz ish clock on that. That looks really weird.
1.02 megahertz.
1.02. So that's okay. The phasing on that looks a little funky though, like it's barely low for not very long. You see? It's not a good flat duty cycle.
Yeah.
Okay.
Yeah, it doesn't look the way that an actually clock should.
Yeah. Can you check pin 39 to see if we're getting a clock back out of the chip? So we're getting a clock back out. That's okay.
But it looks weird too.
Yeah. Bob says you may be AC coupled. Are you grounded to the ground plane of the board?
I'm grounded to the back of the board. Yeah, back here.
Oh, all right. Okay. Well, so we're getting a clock. Are IRQ or NMI being held low? Pins 4 or 6?
Pin which ones?
Pins 4 or 6. Are either of those being held low?
There's 4. That's high.
high.
And 6 is high.
Okay, so that's good. Okay. Let's check pin 34. That's read write. Let's just see if we're getting any wiggles there.
$34.
And it's just high all the time.
Yeah, let me make sure that I have 40, 39, 38, 37, 36, 35, 34. Yeah, but one thing weird with this board, okay? I mean, sometimes I've seen this where when I first turn it on, it will start doing things correctly and then all of a sudden stop. But yeah, It's high. This is high.
Okay, that's cool. And doing things correctly, meaning it seems like it's actually booting.
Right. Yes. It will have chatter over the lines. See.
Okay. All right.
I mean, I'm looking at the ROM right now, so. Okay, go on.
All right. Interesting. I'm thinking.
The reset was 42 and 6 are ready.
Yeah. Do you have pin 3 should be shooting a signal out as well? Yeah, okay. That's fine. I am just checking some things about the CPU just to make sure I'm not missing anything obvious. The Vintage Tech guy says, Joe must have his printer running. Yes, I do. That's also why I have headphones in so I can hear Will. I am checking some things. Even though I have slightly more knowledge about this machine than you, I'm still a relative novice at electronics. Whatever. So, pin 2. Is pin 2 high?
Pin 2 is high.
Okay, cool. That's fine. No problem. Justin's here. Hi, Justin. So that's fine. Interesting indeed. Interesting indeed. Is your probe in 10x mode?
No. That's what I was just checking. 1x.
Okay.
1x up here.
Okay. Let me think. So CPU seems to be running okay. Have you tried swapping the CPU just for flippin' giggles?
I have before with the one of mine. I mean,
okay. Now,
I mean, I can pull out mine. I'll just have to go flip it over and open that up. I don't have it open right now.
No, that's fine. The ROM chip. Have you tested to see if you get good contents out of the ROM chip using a ROM reader?
I have not tried to dump it, but I can. That won't take me too long.
Yeah, let's. I'm trying to think of where we could even get the contents to check it against. Because usually, if you have a copy of it on your computer, you can run basically a buffer check just to make sure the ROM reads correct.
I mean, I can. I'll just have to run. Just give me 1 second here. You know what type chip this is, though, for me to tell the ROM reader?
Brain. Reading. I don't know off the top of my head. Stand by. It's probably a 2732 if I had to guess. Go here. Do this, click this. The primary ROM.
Well, it won't be 32 because it.
Man, this thing's got so many ROMs in it. It could be any one of them. That's the problem.
I mean, it's a DIP24 socket, so.
Yeah, it's probably going to be a 2764. That's a 24 pin, you said?
Yeah.
Then that's probably not the system ROM. That's probably one of any of the other ROMs.
This ROM here.
Yeah, and see, here's the thing: how can we put it? Does that have a part number on it?
341 0031.
0031. Yep, nope, that's the right one. And you're sure it's 34? It's 24 pins and not 28?
Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 aside, so that's 24.
Interesting. Okay, so that's probably a 2716. Or I'm sorry, 2732.
27C0, 27 what?
It's probably a 2732.
Okay, and just pick the AMD one.
Yeah, anyway, for reading it, any one of them is fine.
All right, let's see if we can read the sucker. Hold on, let me turn off this pin detect, because usually that. Reading is fine.
Okay, so it reads it fine, but the question is,
it came up blank.
it came up blank.
It didn't read.
Interesting.
Read as she finished.
Interesting. So here's what we're gonna do.
There is data. Well, no, there is data, but it is further down. It starts at actually 800.
Okay. That may or may not be correct. Stand by. I'm going to switch speakers here.
Okay.
I just have to remember how to do that with my convoluted setup.
Or maybe we have the wrong
Stand
chip.
by. There we go. I just wanted to switch to my actual speaker so I could like hear you while I go and fetch my Apple III. And we'll do some checks against mine. Because they're electrically identical, the ROMs are the same.
Without the ROM, well, see, you get the same thing.
What's that?
A Tech Cowboy says power up without the ROM and see what we get. And I get the same thing.
You get the same thing, yeah. So, let's grab my Apple III.
When you do that, I can probably get mine too and start opening it up just in case.
And everybody's like, why? Why does he have it built that way? And it's because I have to get inside it all the time to do things, to test stuff. This here. So that is chip B9, correct?
I'm still here too. I'm just gonna pop mine open and.
Okay. Yeah, it's 2716. So I'm gonna read mine and see what mine looks like. Okay. My chip. So we can go side-by-side mode here real quick, and I can load the software, which is this. Okay. We can put this in the chip reader. Boop. And we need to do a 2716, 2716. Is it a 2716 or a 2732? It might be a 2716. So we're going to do load. Not load, we're going to read. Oh, yeah. If I do a 2732, do I get something different? Yeah. Okay. So yeah, you'll want to, it's a 2716.
Okay. Well, all right. 1 second. Let me get back to my desk. I was opening up mine. Which one I want to use?
2716.
Okay.
Yep, that makes sense.
2716. All right. Let's read. Read. Okay. Yes. Now I have data starting at 0.
Okay. The first few bytes are like A0, 01, A6, and so on and so forth.
Yeah. A0, 01, A6, 81, 84.
Cool. What's the check? Does your software show you the checksum?
Yes.
What's it?
0x000429E4.
Okay, that's the same checksum I have. So that means your ROM is good.
Okay. So we have no problem with the ROM.
So that ROM is not the problem. Trying to think of what else we could check here. ROM's fine. CPU's okay. That would indicate a really, 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 really low level RAM problem. Did you leave that on when you plugged the chip back in?
I think it was on, yes.
Okay, yeah, be careful with that.
Yeah, I just noticed that too. That's why.
So turn the machine off for me and remove the RAM board. Kick it back on now. That a different pattern?
Yes.
Okay.
Solid. It is now a solid pattern.
Okay. Cool. So that means the RAM is in theory getting addressed correctly because you're getting a how can I put a regular checkerboard pattern because it's just reading whatever the default values are in the RAM from the serializer. Check all those chips under the RAM board to see if any of those are hot.
No, they're not really hot. These actually custom ones here on the side are, but that's it. But the ones underneath are not really.
Okay. So it's not that.
The next ones that are hot are these two over here. But those two are actually custom also.
Yeah, the PALs get warmer than regular chips. That's just how they are. Let me think.
None of these here feel any heat.
Okay. Do you have another 5-volt RAM board?
No, my board is 12.
And I don't know if the 12-volt board will work in the Plus. And here's the problem with the Apple III. There's so little, like, how can we say, experiential knowledge out there about the machines because nobody really got into hacking on them. So I don't want to just randomly throw the 12-volt board at it in case it fries your... I don't see how it could mess up the machine.
Yeah, because
if the machine is designed
under
for a 5-volt
voltage.
board, it's just not going to get the 12 volt it needs to run, so it doesn't matter. But okay, let me think. Thinking. Turn it off. Put the RAM board back on it. And now we come to the which pin did I bend today solution.
Oh, I've taken this on and off so many times.
Yeah. Don't turn it on yet.
Oh.
Okay, that's fine. That repeating pattern on the screen, there's no weird characters at all. That's all the same characters in every one of those blocks, right?
Yes.
Okay, cool. So we don't have like single bit errors or anything wacky like that, unless there happens to be like the same bit in all of the chips in 0 page is screwed up, but I doubt that. Yeah. The voltage coming into the board. I know that you're running a reactive micro power supply, so you shouldn't have any voltage problems there. Are you able to check the voltage coming into the board right at the reactive micro power, right where it connects to the board, to see if you get a different voltage than with your somewhere else on the board?
I can. I'll have to find out which pin it is. I don't remember off the top of my head. I'll have to. Let me go to power supply.
Answered some questions we got here. How much RAM can come off the board, says Thomas Armstrong? I have no idea. It's not documented. Probably one whole row, probably the B row off of that board can come off, and it would probably boot. Maybe. And if it does, it might fail a diagnostic check like a RAM check, but we'll see. Could it be one of the customs acid rain? Sure could. And if it is, the only way we'll know is by throwing a replacement customs in it to see if it fixes it. Because we have no way of testing any of those customs.
All right, a schematic is saying
to just replace the custom with a known good custom than it is to try to like put it in some sort of test frame and run it through all the stuff it can do. Check all the AC voltage. That's what we're checking next. Clock signal is everywhere stable where it's supposed to be. Well, 1-bit fever dreams, we know at the very least the entire video section of the board is getting a stable clock because the raster is locked on the screen and we're getting a perfect video signal. So that's not an issue there. We also checked the clock on the CPU earlier, and the CPU seems to have a good clock.
not getting a connection here. It's supposed to be pin 2 and 3 is actually positive 5 volts.
Okay, but you're not getting a good connection.
Well, I'm unless I let me look on the other side of the board, see if I have a better.
Yeah, if you just flip it and check it on the back.
Yeah, well,
The
that's.
pins go all the way through. You should just be able to check it.
Let me undo some of these that I don't need.
Thomas Armstrong, he's saying, I'm guessing it's not as simple as looking for bad LS244 and 245 parts. It might be. It might just be a bad connection between the CPU side of the machine and the RAM. But we're testing the dumb things first.
One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I'm getting 4.85 in.
That should be all right. The machine will probably run okay down to 4.6 at the worst, but that it starts to get flaky there. So we'll come back to that in a little bit. So if you replace the caps, any shorts? Yeah, there's no shorts acid rain that we're aware of. So yeah, the next thing we do is I like the 1-Bit Fever Dreams statement next is let's check the clock signal on some of the other big chips here. So let's look at the clock on the 6522s. There should be 2 of them in the machine.
Yeah, there are these 2.
And the clock on that is on some pin that I don't remember. It should be on pin 25. And it should be the same. It should be the 1.023.
All right, I'm coming. All right, we're back on. Which pin you said? 20?
Pin 25. And folks are asking to see what the waveforms look on mine, so I'll go ahead and get that set up.
Right there. That is 25.
Okay. So you're getting a clock. You have like a DC offset. Like everything is, there you go. That looks better. Did you have to change a setting or something?
Yeah, I just actually pressed auto.
Oh, okay. Let me turn on my scope. I wanted to try to get a automatic capture of my scope screen for the longest time, but it involves like installing all this crazy Python script crap. So let's do this. We're going to make sure this machine is completely isolated because it barely fits on my bench. Where is it? Do it. Do it. Plug in. Turn on. Cool. So we can also go to side cam, probably. Stand by. Get that set up. And boop. Boop. And super zoom. Whee. So I need this to go to the side slightly. Cool. So let's see. My 6502 37, that's the main clock. That's what mine looks like. Is that what that's supposed to look like? I probably also have the trigger set wrong. 6502 pinout. I'm pretty sure pin 37 is the clock. Come on, internet. Yeah, 37. Yep. 40, 39, 38, 37. Yep. I just have the trigger sets. Spot. I just have to remember how to set that. Stand by. My scope is way too freaking complex. Source, channel 1. Yep.
That's why I bought a $60 one. I do have a bigger one too, but it's
Channel 1. Yep. So, yep, I'm getting a funky frequency, but I'm getting about 1.49 megahertz out of mine.
that's on pin 20
That's on
25.
pin. Uh, 21, 22. 20. I don't know if I can get to 25 on mine. 21, 22. That's this pin right here. No. On pin 25, I'm getting 1.023, basically.
Yeah, well, that's what I'm getting, 102.
Okay. On your 6502 on pin 37, what are you getting?
On 37.
Mm-hmm.
$102, but I'm getting that weird.
Okay. You're
I'm
getting
still
like it's
102.
high for way too long and it only dips low for just a tiny fraction of a second.
Yeah.
Yeah. And the thing with that is that if the 65, if you think about it, 6502 has a certain frequency it can run at. And if that low time isn't low long enough, it's effectively like you're overclocking it. He says your probe should be at 10x mode, the little slider on the probe. In your right hand, the slider on your probe that is in your right hand. There's a little slider on the probe itself.
Yeah, no, that was a 1x.
Put it at 10.
Okay.
Then check it again. Yeah. We're still here, and I'll show everybody. We're still that signal. It's not square. It's like pulse width modulated. The low periods are super short. Yeah. So that has me suspicious. So let's look at the schematic and see what generates the clock for the 6502. That's just phase 0. So where does that come from? I'm going to just show you that I'm looking at that right now. Because if you look at it here, if you look at it on mine.
Yeah, you seem to have a better copy.
Let's do this. If I hold reset, control reset. It's weird. It's hard to do this all at with one hand. Yeah, that's interesting.
You're getting the same thing there.
It's slightly different though. Stand by. I want to. I'm going to grab onto that pin, put this in single shot mode, then turn it on. Yeah, so that's the single shot. So you can see on mine, right after turning the machine on, here, right after turning the machine on, I have a similar disparity in the clock. You see that? How it's like 1/3 low and 2/3 high.
Mm-hmm.
So that's not indicative of much. I don't think that we have a problem with the CPU or the clock itself. Okay. Bob Darlington. Yeah, so Bob is like one of the best people to have on this stream right now because, oh my gosh. Yeah, the guy, Bob, we love you, Bob. I've been using and repairing oscilloscopes for about 35 years, partway through writing a book on their use. So, so see, what's happening there is that it's obvious the CPU isn't getting the point where it runs code, but it could be something else, because when you look at my signal after it's running, you can see that it goes into this weird kind of asynchronous mode. Here, I'll show you again. See, it's got this weird asynchronous signal. See, if I like single shot it, it's like moving all over the place between all these different modes. Like there's a good shot right there. So the first, and it's because the Apple III had the CPU a lot of the time will run fast, if that makes sense. And then when it's doing certain I/O functions or video functions, it slows down, then comes back up to high speed. So what's happening is yours is never getting to the point where it triggers the circuitry to tell it to do that other stuff. So I don't think it's a literal clock problem. We're coming back to it's not, the machine isn't running code. So looking at the schematic, it's either address or data lines. Now they could be wiggling, but that doesn't mean they're actually like getting what they need to get. So that would make me wonder if it's the 8304 chip. Which on the original is in location C3, but on yours, because your computer is completely different, could be literally any friggin' where else. It's going to be down in that area.
What is the chip number?
C3. The actual... Oh, the chip is an 8304, 8304. In my case, let's see if we can go to bench.
Yeah, 8304, right here.
Yeah, and in my case, it's that same location. It's right here. So, can we look at... It's going to be hard. You might have to put your hook clip on it and then put the RAM board back on it. Can we look at pin 3 of that? Pin 3 is the enable line for that chip. And I want to make sure it's being properly enabled. It should be enabled low. Is that pin 3 or 9? Stand by. It's pin 9, not pin 3. I take that back. So the schematic is very hard to read.
2, 3, 4, 5, 6, 7, 8, 9. So it's almost the last pin on the side there.
Yeah. It should be like a 20-pin chip.
Yeah, it is.
So yeah, you want to check pin 9.
That's my signal.
What's that?
That's my signal there.
It's wiggling. Okay. What do I get on mine? Let's see here. Just run. Should be... my scope is caught on things. 1, 2... Where's the... That's that. I can't get to mine. Because it's under the board. But I'm going to assume... So it's enabling and disabling, and that makes sense because... The 6502, the processor really only should be talking on the bus on every other cycle because it's CPU, video system, generally speaking. So that means that chip, at the very least, is getting the signals it needs to go to wiggle back and forth. Okay. So we have the next step out would be the chips at D2 and D3, at least in my case.
Yeah, those are under the board. Oh.
Ooh, what? Did you notice something?
Those are under the board.
Okay. Well, at the very least, we can see if they're doing something. If they have the right enables and all of that stuff.
Those are the two SU57 chips.
Yeah, the 257s.
Yeah.
Let's check that they're getting their enable signal. They should both.
Can I do that without the memory in?
You should be able to. Yeah.
Okay, and which pin number? Do you know?
You pin. I am determining that now. Are they 14 pin chips?
1, 2, 3, 4, 5, 6, 7, 8. No, 8 pin.
There's
8 pin
16
aside,
pin.
so I mean 16.
16 pin chips. So I believe it's going to be pin 15 should be low.
Okay,
On both.
board on 15,
It's wiggling.
wiggling,
Okay, that's okay. It means
and
something. It means it's getting its logic is driving them. So
both of them wiggling.
okay, that's okay. So that means they're being driven.
There they are. Oh, sorry, my
Pin,
big head was in the way.
no, you're fine. Pin 1 on both of those should also be oscillating, I would think.
Pin 1 is high.
Okay.
Is high on both.
It's high on both. Okay, that's fine. Okay. That makes sense because, well, they shouldn't be both high at the same time.
Yeah, but remember, I don't have memory in here, so that could have an impact.
Maybe.
I mean, I can reach pin 1 with the memory in there.
A B A B A B A B A B A B A B. Okay.
Yeah,
Okay.
I can reach pin 1 with the memory in there. So let me see. Where did I put my light?
That is a 74 LS257. I'm checking to see what the
All right,
S257
there is pin
was,
1. There is pin 1 with the memory in it.
and it's oscillating. Okay.
Yeah, that's
So
on the first chip, and then on the second one, same thing.
Yeah. Okay. So that's fine.
Okay.
I was just going to look at the data sheet for that. Yeah, that makes sense because it's switching between the two A and B sides. Okay, because it's a multiplexer. Okay, so they seem to be multiplexing at the very least. Right now, I'm really just checking control signals, if that makes sense, just to like make sure things are getting their controls and all of that stuff. Okay. Thinking. Okay. Okay. So that's an address buffer. That's, yeah, so that just connects directly to that at the low end of RAM. Okay. Addresses, and those two jump up because, yeah, I'd only select them when it's I'm just reading the schematic right now. Oh my gosh, MacFX gave us a $2.99 super sticker.
Cool.
Woo! Thank you. Acid Rain says, I'd like to know how to use a scope. Plug it in, poke bits, and watch it wiggle.
Yeah. Hey,
and then
guys,
go on the internet and see how to read it. I am the worst person to be asking how to use a scope. I barely know how to run.
Y'all that are in the chat that don't know me too well watching this, okay? I didn't start this hobby until February in 2022, okay? And I didn't even own a scope, know how to use one. I never started a damn thing before actually February, okay? So, and actually, look how far I've come in just almost actually a year. So, and it's just practice, trying, do not give up. Watch videos, watch shows. Joe and Bruce and Steve. I mean, geez, I can't tell you how long I was watching them before I even decided to go ahead and do it. So, I mean, hey, if I can do it, everyone can. But then again, I have been in the tech field for my entire career, but I never did this type of work. So anyway, let's go on, Joe.
Yep. I am looking at other things here that it could be. So we've checked we've checked the data side, and all of the chips at the very least seem to be getting their enable signals, which means that if their data is wrong, if they're getting their enables, but their data is wrong, that would you would usually think that the machine would like try to do things and crash and do weirder things than just a static pattern. The static pattern seems to like indicate to me like it's getting no data at all, or it's just being utterly misaddressing. So, Zodium Retro, Money Gib. Zodium gave me $2.80. Thank you, Zodium. You're the bomb.
Hey, who was the one that? He was in a channel last night. He gives actually 1812 Canadian or something about to actually remind people of the war. Who actually won that war or
Was
something?
was that Retro Techie? I don't know which one.
No, that was Garage Guy.
Oh, okay.
The
Everything is
Canadian
broken.
one.
Garage,
Canadian
yeah.
one. He says that he always gives actually $18.12 or 1812 just to remind
us who sacked the Washington D.C. and burnt down the Capitol.
I just had to laugh at that.
Our wonderful allies.
Yeah, Thomas, okay. I enjoy desoldering and soldering just to see how that flows and how it works. It's just amazing. It's just so nice when you have the right heat and the right solder and the flux. Oh, it just flows so nice.
It goes goo. Yes. Yes. There we go.
There we go, Eric. Yes.
The White House is white now. Yes. So let's look at the addressing side coming into the 6502. So that's going to be, generally speaking, D6, D7, and D8, which should be a 244 and two more 257s.
Can I do that without the memory, you think, or is it going to give me problems?
I'm looking.
Because it is under the memory.
No, you're going to need to be under the memory board, which that's the problem. Is like, how do we diagnose that?
Which chips?
The board upside down?
Yeah, well, that's what I'm thinking. But I mean, which chips did you say?
It's supposedly D6, D7, and D8, which would be D6 is an LS244.
Correct.
The D7 and D8 are 257s.
Correct.
They should be all relatively near to each other.
Yes. Okay, so if I'm going to do these from upside down, so one is going to be that side down towards me. Okay. All right, here we go. We're gonna try.
Let me know which one you're checking. Is it if it's the 2?
Well, I'm gonna start with the actually 108 with the LS2 244 first.
The 244, got it.
Okay, let me get the memory back in there and then flip it over.
Zodium Retro has it right. I think the thing to keep in mind is you're going to break a lot of things and have a hard time with things before you, quote, get good, unquote. Agreed. Thomas Armstrong. LS chips. Gotta love them. Yes, LS chips make the world go round. You can build literally everything out of LS chips as long as you're not trying to go too fast.
All right, I'm just marking which ones they are on here so I know.
Oh, yeah. Yep. I get that.
So one is down and closer to me. Okay. All right, and I don't need video for this, so I'm going to undo that.
A trick you could do is, like, take a picture of the top of the board and then in a text editor flip it backwards and upside down or something so you know where they are, but that's fine. So the LS244, the main thing we want to check are...
All right, board is on, so we can check.
74 LS.
I'm sorry if my head is going to get in the way, guys, but it's just I got to see this good. All right, so which pin on the LS244?
We want to check pins 1 and 19. This should both be either low or receiving low states of some kind.
Well, this is 1.
Okay, and it's low.
It is not even budging really.
Okay, that's fine.
It's budging a little bit, but it's staying low.
Yeah, if you're getting a tiny bit of budge, that at least indicates that something's going on that line, so that's fine.
Okay, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19, same thing.
Same thing. Okay, so those are the two enable lines for the 44, I believe. I just need to double check that against the data sheet. Yeah. Yeah, it's
And
1 and 19. And that's for the 240. This is the 244. It's saying one is low and the other is high. Stand by. Low is low. Yeah, 1G and 2G there. And they have the inverts on them. Okay, cool. The 244 is mislabeled in this diagram. You see this? You see how it doesn't have the bar over it? It's mislabeled. That is wrong. Because we can tell from the truth table here. See how they both have the bar over them like they're supposed to? Yeah.
Thomas is saying the LS244 is non-inverting.
Yes.
Okay.
Which means it when it brings the signal in, it sends it straight back out.
Okay.
Unchanged. Yeah. So that's fine. So the fact that both of those are low means that the 244 is operating. So that's good. Or in theory, it should be operating. So now in theory, on the 244, if you check pin 2 for a signal,
high,
and then check pin 18, it should be the exact same thing.
high, yeah.
So now check 3 and 17. They should be the same.
3 and 17, yep.
4 and 16.
4, it's not as high as the other ones, but yeah, 4 and 16 are the same.
Okay. 5 and 15.
5 is high, 15 is high, the same level.
Okay. That's actually somewhat concerning that they're all staying high because they're part of the address bus, but we will come back to that. What did we do? 5 and 15?
Did 1, 2, 3, 4, 5. I just did 6 also while you were.
Yeah, so it's going to be 6 and 14.
Yeah.
And then 7 and 13. I may be looking at the wrong schematic, but they are the same. I'm looking at the entirely wrong one. Stand by. It's going to be 2 and 18. 5. Yeah.
Sorry, which one?
Double check 2 and 18. I may have been giving you the wrong pairs because I was looking at the wrong chip.
Well, yeah, there's 2.
Okay.
And then 18.
Okay. Go all the way and check 8 and 12.
8.
Yeah. That seems to me to be floating. It's barely doing anything. You see it's not going all the way to 5 volts. Do you have a trigger or line or whatever you might call it, a measurement line? Or do you have the scope set to where you can know where 5 volts is on it? I mean, I can't see it from here, so I don't know how you have it set to know where 5 volts is on the screen.
Well, 5 volts is going to be right at the next, actually, because I have a graph.
Division.
So
okay, you have it set to volts per division. Do you have it set to 5 volts per division?
Yes.
Okay, so you can tell when something is high because it's like right at that line, but you can tell if something's floating because it's like kind of in between.
Right. It is actually in between them. It's at about 2.5 volts.
So that's floating. So that means that chip isn't working right. Interesting. So, or not necessarily not working right, but not getting what it should get.
Mm-hmm.
So,
what's feeding that chip?
What's that?
Go back one.
What'd you say?
Go back one.
Also, your probe ground on the left may be grounding out the board and doing weird things. Right in the middle of the board, the clips, the 2 black clips, right, literally in the middle of the board.
Yeah. Okay. Yeah.
Don't do that.
Let me
causing problems.
Let me actually cover those because they're supposed to be.
Yeah.
They're supposed to be like actually that covered where they don't.
Yeah. There you go. Okay. The next thing we would probably want to see if you can run this diagnostic with the video plugged in, so we can make sure the machine is still running and on. because we can't really tell. I mean, it's warm. I'm sure you could tell, but
I can do the video. Yes, I just gotta.
because it's possible as we were working with it, we set the machine in some sort of funky, like, locked state.
Yeah, I'm getting a different pattern now.
Yeah. Do you have the memory board in it?
Yep.
Interesting. Double check that memory board.
Yeah, that's.
He broke it worse, everybody. Blame him.
Yeah, no, it's in good. Let's see. There. Okay, we're
There,
back to normal.
Those messages, yeah. Those connectors, they get yucky. Okay, now let's check those LS244s. Let's check pin 2.
Floating.
It's floating. Pin 2 is floating. Check pin 8, if you can find it, on the 3410031 ROM.
Okay, the ROM is this one. So 1, 2, 3, 4, 5, 6, 7, 8. Floating.
It's also floating. Check pin 9 on the CPU.
CPU up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Floating.
The CPU's entire address bus is not functioning.
No.
The only thing that is attached to the A0 line is the 3410031 ROM chip and the LS244 chip that we were just testing. We know the ROM chip is good. So that means your problem is, in theory, the LS244, the CPU.
Mm-hmm.
So you said you've swapped the CPU already, right?
Yeah. Yeah, but we can try. We can do it again.
I would say let's just go ahead and swap the CPU. Actually, can we flip it back over?
I do have a 244, but it's a 244 NE.
Oh,
but it should still work. All right, let me turn it off before I flip it back over.
Okay.
Okay, yeah, I had it like this last time.
Okay. What we're doing is I'm checking to see if the CPU is even like connecting to its socket correctly.
Now the actually CPU is getting hot.
Oh, that could just mean that it's getting power.
Yeah.
But the rest of the connections aren't connected.
Okay, video's connected.
Okay.
A little bit of a different pattern, a little bit of stuff different on it.
Interesting. Okay. So, yeah, I have my theories. So, turn it on and check pin 9 on the CPU again and see if you get anything. It's just floating.
Mm-hmm.
The CPU, no matter what, unless its bus lines are being drugged down, should be wiggling the address lines at all times. It is going to always try to execute code.
I'm getting that on 9. Look.
Yeah. You're getting kind of really low wiggles.
Garbage, yeah.
Interesting. Interesting indeed. Like it can't drive the lines. Interesting. I would suggest turn the machine off. Pull the ROM chip out. The 3410031 that we did the test on earlier.
Okay.
And read that chip again. Read it with your reader, just to make sure that because you plugged it in when the machine was on, we didn't make We didn't like make more problems for ourselves.
And I don't think we.
I mean, it's probably fine. Those chips are usually not a problem, but you never know.
Yeah, I'm getting the same. I'm getting the same data.
Okay, so that it's not that chip. With that chip out, turn the machine back on. Same pattern on the screen. Check address 9 again, or yeah, pin 9 on the CPU again. Barely any little wiggles, isn't it? Like it's trying, but they're not even there. Do me a favor and check pin 8.
There you go.
Are you sure that's pin 8?
One,
Pin 8
two,
is VCC.
three,
It should be
four,
5
5,
volts.
6, 7, 8. That's 8.
So the CPU, are you sure you're checking this? I'm sorry to ask really stupid questions. You're checking the CPU?
That's the CPU right here. So 650028.
6502B.
I'll be B or 8.
Okay, cool. Turn the machine off. Take the CPU out. Oh, look at you with the fancy CPU puller.
Well, it's a bigger chip, so I want it to be, and I don't have too many. I only have one of these spare.
Okay, that's fine. And turn the machine back on. And like it's just garbage on the screen, but that's fine. Check pin 8 again.
See it?
Yeah, yes. So pin 8 is the lower row, 8th pin in, and you're not getting any voltage there. That should be 5 volts. Pin 8's the VCC pin. Like the CPU's not getting any voltage, or your scope is set weird.
Well, if that's the voltage pin, I mean, with my normal meter, I should be getting 5
should
volts,
get 5
right?
volts there. Yeah.
$4.85.
4.85. So let's let's see if we can get the scope to work first, so we're checking the right things.
So a meter's giving me that.
Right. So we need to get the scope to show 5 volts or 4.85, but we need to get the scope to measure the right value on that pin. It's got to read high on pin 8. Until it does, we can't trust that scope to be doing our diagnostics. Also, people are asking, did the ground fall off your scope? Is it still connected?
No, it is. It's on back here. I mean, I'll move it to a better pin. Yeah, I'm getting it there.
So you're getting 5 volts now.
Okay.
Okay, cool. Now let's put the CPU back in and check that again.
8. You see? Yeah, there's 8.
Yeah, good. Okay. Cool.
There's 9. Okay.
Yeah, 9 will do nothing right now because the CPU's not in it.
All right, it's
let's
off.
put the CPU back in and double check pin 8, which it should be 5 volts. Okay.
Yep.
So pin 8's 5 volts.
And 9 is also high.
9 is just high.
Yeah.
All the time, just high.
Yeah.
It's not wiggling or doing anything.
No, there it is right there. Oh, the light is kind of shiny bad. Yeah. So
check pin 10. Actually, just go through between 9 and 16 and just check all of them.
Okay, so there's 9. There's 10. 11. 12.
Yeah.
13, 14, 15, 16.
Gotcha. Okay. And the ROM is out. So it should be trying to run. It really should be trying to run right now.
The ROM is out. We don't have the ROM in.
And that's fine. Even with the ROM out, the CPU is going to fetch FFFE, fail FFFF, get garbage, try to execute whatever's at the garbage, and reset over and over and over again. It'll just get stuck in basically a reset loop. So you would still be getting wiggling out of it if it was trying, like literally, like the 6502. If you get power and ground, it'll try to run.
Mm-hmm.
Like the address lines will wiggle, and the fact that we're not getting it wiggling is telling me that CPU is not even running.
So you want me to pull my actually CPU out of my 3?
I would let's step back one step and try one other thing.
Okay.
And pull the LS244 out of the board just for giggles.
All right, ROM out or in? It's because remember
ROM
it's still out.
Yeah, ROM out. I'm trying to get the CPU itself to do something by itself. If that makes any sense.
Okay, so pull out the 244.
Mm-hmm.
Matt, Steve is in here.
Oh my gosh, why is Steve here? Hi, Steve. We love you.
6B is in too.
Crotch waffles.
He's got one hand that looks like it's got money in it, and then the other one, I don't know. Poor Apple III Plus. Jake, we are working on it.
Do we have clock on pin 37? Mike, we checked that very, very early on. Yes, we do have clock on 37.
Okay. 244 is out. Memory back in.
Leave the memory out.
Okay.
Leave the memory out.
All right.
Like I said, the CPU is going to wiggle whether it does not matter. If you give 5 volts and ground to that CPU, it's going to run. And pull reset high. You give those 3 things, and the CPU will just run.
Okay, look.
So with the memory out, the address is doing stuff.
And don't forget 244 is out also.
244 is out. Interesting. Throw another 244 in it. With the power off.
It's off. Okay. 244.
Mm-hmm.
All right, I gotta see which one it is because in each tray I have 2 different chips.
Everything is broken garage is responding to Steve. Now I want a feed of waffles. Oh my God, I would love to have waffles right now.
We have a place down here called actually, what's it called? What is it? Waffle Monkey.
Waffle Monkey. Oh my God.
And they have amazing waffles, man. Their waffles are just amazing.
Sends waffles to Joe. Yes.
I mean, you can go in there and get an actually chicken sandwich waffle where the actually bread is made out of waffles.
Oh, chicken waffles!
It's to die for, man. I tell you.
Here you go. Steve gave them their new logo there, Waffle Monkey.
I'll take a picture of their logo. It's a big old monkey on it too with waffle. It'll be perfect for us, Steve.
Waffle Monkey.
All right, this is a 244 NE4, so
that should be just fine for testing.
I just want to make sure. This just says 244N on it, so it says the same thing.
Yeah, it's fine.
Okay.
It's all interchangeable. You could probably put an S244 in there, and it would probably work fine. You could put an HC244 in there, and it would likely work fine. An HCT244, it doesn't matter. At the very least, for testing, it really doesn't matter. Let's just leave the RAM out for now.
Yeah. Why can't I get this to go in? I need to bend these legs a bit more in.
Sorry, I just wanted to show my face there for a second. I'm here, people.
We're both here, but just can't see us.
This is fun.
All right, the 244 is in.
Good. It's in the correct orientation, right?
Yeah, it's the same. It's the same.
Or else you're going to have a pin. You'll have a chip ejector event. Okay, cool. Power that on. Check pin 9. Do we have wiggles?
No.
No wiggles. Interesting indeed, which means the two. How is that possible? Let me think. If the 6502 is bad, the 244 being loaded down could cause the O2 to not run. You would still see something, though. So pin 9 dead. Pin 8 got power on it. Just make sure, again, that our scope is working correct.
Yeah.
Yeah, and 9 is dead.
9 is just high.
It's high.
Okay.
Interesting.
That's pin 1. Pin 2 is high. 3, I've got data on it. 4 is high. 5.
Yeah,
6,
let's look the 6502 schematic.
7, 8. 8 is high. 9 is high. 10 is high.
Yeah. So the 60. Just give me the freaking pin out. I don't want all this. Just give me the pin out. Thank you. So pin 1 should be low.
It's just sitting. Yeah, it's just sitting right at 0.
2 should be high or wiggling.
High.
3 should be wiggling.
Yep, lots of it.
4 should be high.
Yep.
5 should be floating or something.
5 is
5's
low.
mid C. It shouldn't do anything. 6 should be high.
Yep.
7 should probably be high.
No.
7 is low. Okay. Boop, 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 boop. Boop, 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 boop. I just have to remember what the sync pin does. 6502 sync pin. Sync pin behavior. Oh, it's high specifically for the first byte of the opcode fetch. Yes.
That's on 5?
Yes. So, in theory, 7. Pin 7 should basically if its code is running, you should see it kind of wiggling high, sort of kind of low.
Well, it does a quick spike
right when you
wiggling
turn it on.
right when you turn it on, and then it goes low. I mean, if you can see this, yeah. See,
Yeah.
it's so fast you don't see it on the screen.
So that's fine. So it's low most of the time, but that just means, again, the CPU is not running. So, and it's like really not running. And we know none of the address pins are doing anything. Check pin 34 should be high.
$34. Yeah, well, it's not really 5 volts, but it's up there.
Yeah, that's fine. It's gonna just hover around VSS or VCC. 40 should be high.
Yeah.
39 should be oscillating.
Yeah, that's your clock. I mean, that's...
Yeah. 38, what's it doing?
38 is sitting...
It's floating.
Low.
It's low. Okay. 37 should be oscillating.
Yeah.
Okay. Let's put a different CPU in the machine, see if we get something different.
All right, you'll have to give me a second. Let me finish opening up this one and take it out.
Sure.
All right. You remember earlier I was talking about the memory boards.
Yeah.
Okay.
Oh, yeah. Here, I'll make you big so people can see what you're talking about.
I mean, I can actually pop it out. It doesn't matter. I mean, um,
That's
you can
cool.
see.
So you can just put the 2 chips in it. It converts it to the 1, and so you don't have to do all that weird hackadoodle.
Right. It's
Cool.
it's already on the board. All of the trace work
Yeah.
is already on the board, and that was designed by actually Jake. That's right there. He's the
That's
one that
awesome.
he's the one that did the board work. But now the problem is that it is too wide, and it sits on top of the other chips.
Mm-hmm.
So what we've done now is that we designed it because you've got a lot of room here.
Mm-hmm.
So now it will sit actually lengthwise this
And
way.
it kind of hangs off the back, so you could do a
Yeah.
whole row of them if you had to.
Right. Yes.
Cool.
Because you see
I
right
would.
now. Yeah, I mean, it's just a small little thing. I mean, you just got to put on some actually headers, and then the two
Yeah.
sockets, and that's it. The nice thing
That's
is
cool.
with it is that you don't have to cut anything off the chip. You don't have to bend any legs or nothing.
You solder it together, shove it in the socket, and it's like
Right.
problem solved.
Yeah.
I like it.
So
Nick, I
anyway,
like it. It's awesome.
that's what it is. I just ordered some actually version 1.1 of them because um, we saw the mistakes and things to fix. So all right, let me take out this CPU. Okay, there you are, right there. It's the same location, so it's not a problem.
Yeah. And that's a regular 3. So
Yes, and this is a working 3. I mean, this
for
one
now.
here, man, that chip was in there, but it's in there nice and good.
Yeah.
Okay.
Of course,
You
you've
see,
already replaced that
this here
socket.
board too was very rusty, and I completely sanded it down with a wire brush, and then painted it over again, and it came out very good.
Oh wow. Can I ship mine to you and you can do mine? I won't pay you to do it. Get it? Get the
Well,
joke?
if you want to send it, it's fine.
It might take 6 weeks to get there.
No. You would send it to You would send it to the house and over in actually Florida, and then I would bring it down with me.
I'm kidding.
It's not the same. I mean, it's the same place you send all the stuff that I buy from. Well, no, sometimes I send it to an actually forwarder, where then I get.
Is that a turned pin socket?
Huh?
Is that like a round pin socket?
Yeah.
Okay.
Yeah, and I found out that these round ones do not like chips with very short legs.
No, they do not.
I found that out when I was doing the actually SE30, where the sound chips would not sit in good, and I had to revert to the old to the other type of socket. So in actually some cases, these actually round ones are good, but if you got short pins, forget it. And I was gonna mention that, and that's what's making me think about this ROM. Okay, because it sits in there very loose.
We may want to put double wipe sockets on those. I prefer dual wipes when we're dealing with dip chips. They tend to just work better.
Okay, I need to see good here because I don't want to bend any of these legs.
You take your time, man. That's the other thing too with the turn pin sockets like that. It's really hard to get them perfectly aligned to get the chip.
Yeah. I'm across here now because
And then before you send it back to him, replace that socket with a
Double
with a
wide
dual
one.
wide socket. Oh, excuse me. Huh.
See, if I had a double wide one in there, it would be in now.
Yep.
Hold on, I want to bend these legs a little bit.
Yep. Take your time. You need to get yourself one of those pen flatteners.
Yeah, I seen you all with them, and I meant to order to try to find one so I can order one. But okay, there we go. Yeah.
There you go. Here's your part.
Yeah, no, I just want to make
part number 99363. I'm sorry, I talked over you. What'd you say?
It's okay. Yeah, I need to find it and order it. Add it to my wish list on Amazon, and then when I go up, I order everything. Okay. CPU in. So now try it again with memory out or in.
Try it with memory. Yeah, let's just try it with memory out. I just want to see the address lines wiggle to make sure it's working correctly. Now that we put the 244 in.
All right, ROM is out.
And we want to check pin 9.
No.
That is weird.
Not even getting anything.
So check pin 8. Make sure we're getting.
Yeah, I'm getting current because I've got other things
Okay.
dancing around. 1, 2, 3, 4, 5.
I like the term wiggle because it's funny. Yeah, pin 8 should be 5 volts.
Yeah.
Pin 9 is address. That should be just going like crazy.
1, 2, 3, 4, 5, 6, 7, 8. Okay, there's 8 going up.
Okay.
There's 9. It's not. It's just going up, and that's it.
Okay.
It is not wiggling.
Okay. The CPU is not running code. It's not running code. It's not the reset line.
If I take out 244 again, let's just see, because remember with that 244 out, we were getting wiggling.
Mm-hmm.
And I'm getting wiggling, you see? Let the auto thing do its thing, and then you'll see. You see?
Mm-hmm. You see, it's a nice even pattern. It's fetching, crashing, fetching, crashing, fetching, crashing over and over and over again. That is weird.
Yeah, you see?
I need to stare at the schematic for a minute. Why would that have anything to do with that?
As soon as I take 244 out, it works.
The only thing the 244 is doing, those are inhibit lines. That's the bus. Just want to show everybody what I'm looking at here. So we've got, do I have my pin attention application so you can see my pin?
Thomas, a short under which socket and where?
So if it's a short under a socket, it would have to be under the 244. Right? Somehow?
Yeah, because that's the one that is causing everything. I mean,
Just
that's
an inhibit line. It goes from here, goes from here, goes from here.
you got that 108 resistor there.
The DMA. So basically what it's doing is that inhibits all of that while it's running. It inhibits memory, it inhibits the address lines. That's fine. That makes sense. That's just the address. None of that matters. That's not connected to this in any way. That's not connected to that in any way. Yeah. Bye, 6Bs. Gotta go to bed. See ya.
Night.
It's acting like a pull-up resistor, the 240. Yeah, like it's just pulling the whole damn thing up.
Yeah, but what is going into that 244? We've got 5 on that 19 on that pin 19 is the 5 volts, right?
Pin 19 and pin 1 should both be either 5 or 0. I need to look that up.
No, but yeah, you see that's the thing. There's 5 volts that goes to resistor pack 14. Then it comes down to an actually LS4 at actually K9 right here.
Yeah, so it's being pulled up, and the 04 flips it back to down.
Yeah.
So that it can be controlled by this TSA, whatever the heck this line is right here.
Yeah, I can't read that too well either.
Yeah.
TSA0B or something like that, it says.
Yeah, it's hard to read it. J12
on J15 through 22.
22. So that just goes to some jack somewhere. Those these right here go to the sockets, I'll bet you, or go to the slots. So that a slot can do DMA. So it can inhibit the CPU and talk to the memory directly.
Yeah.
That's my guess. Trina, hi Trina. We're doing hyper techie stuff. It's fun. Those are just pull-ups. LS04 at K9. Interesting.
You see, with 244 out, look at what I'm getting on 19, and I wasn't getting that when it was in there.
So you have a bad 244 and then put in another bad 244?
It's a brand new one that I just took out, and I just bought these from actually Mauser.
So that is wild.
I mean, I can try another 244.
The 244s, and yeah, see, the 244s are just an input line. They shouldn't have any. Or the pin 1 and 19 are inputs to the 244. The 244 should not drive those high or low at all.
Oh, well, hold on. Sorry, I was looking. 19 is here. Sorry. This is 19.
It's just low.
It is nothing.
Okay. Pin 1 should be exactly the same.
Yeah.
With it out.
But pin 2, I'm getting that. 3.
Yeah, pin 2 is the same as 9 on the CPU. That's an address line.
Okay. Yeah, so I'm getting so I have the address there, and then
okay. Hang on for a second, I'm thinking.
Then I have it here on the CPU.
So pin 19 is low. That's just being driven low. It just works. Turn the machine. Well, that would be hard to do. I'm thinking very poorly. Give me a moment. $29 watching and only 20 likes. Smash that like button. Do it. Thank you, Trina. Rudy's here. Hi, Rudy.
Eric, it's about Apple III, so it needs pull-ups.
Yeah. So it seems like
depends on that. So no pun intended.
Yeah, that's pulled up, which means that pulls down. So without the 244 in that, pins 1 and 19 are low, correct?
1 is, yeah, it just goes up a little bit, just a dash. 19, the same thing.
Okay. What logic changes the tri-state on the LS244? It's the pin he's checking right now, which is the LS04. Which the only thing that's changing the tri-state on the LS04 is whatever the TSA0B signal is right here. This.
Yeah,
It's
where's
the only
that
thing
coming
that
from?
affects this line. Can you turn the machine off and just for poopies and giggles use your meter thingy, the beepity beep meet machine, and make sure pins 1 and 19 have continuity on the 244? Just to make sure I'm reading the schematic correctly, because this is the world's shittiest scan of a schematic. Sorry, poorest scan. I'm not supposed to swear.
Yep.
Okay, cool.
I got the beep.
So those are connected. Okay. So again, if we look at the 244, that's then, and it's, yeah.
Yeah, but I'm wondering where that TSA0B is coming from, because that's got to be low, and enabled is low.
Right.
And that's what's going into pin 3 on the...
Now keep in mind, if pin 3 is receiving a low because it's an inverter, the other side would be coming in high. Right?
Mm-hmm.
So...
Well, that's what I want to check is actually LS04.
We can check the LS04 to see if it's like getting a low and putting out a low or whatever. I'm going to go hunt through the data, through the sheet here, and see if I can find where the signal is coming from while you're doing that.
3 is going in high, and from 4 it should be coming out low then, and it is.
Okay. And that's K9 or somewhere in that general.
Yeah, right here. And it is a 74 LS04N.
Okay, so that's cool. Schematic diagrams. I want to open this in this tab. And where the heck could that be? It might be IO logic.
Yeah, what is that TS? Where is that coming from?
Yeah, I'm hunting for it. Interprofile. It's not address logic because that's what we're looking at. Well, it might be. Let's look at it. Oh yeah, this is just the memory addresser. Yeah. We're looking for, it says something 12 on J1522. Right? So that indicates that like that's a jack. Right? That's a slot or something.
Yeah, J15. J16 and 17 are the two for the memory.
Okay.
Okay, J7 is the keyboard. J6 is the internal floppy. J20 power. I don't see no J15.
Here we go. J. J12 through J15 are the peripheral connectors.
Okay, so
it's TSADB. There's our signal right there. T5ADB or whatever that is.
T5ADB?
Yeah, this one right here. It's pin 22.
Yeah, but there's nothing there that would be driving that.
Yeah, it's empty. Unless, that wouldn't matter. Putting that chip in shouldn't matter. Okay, so let's try something else. Put the 244 back in.
The actually original or the?
Doesn't matter. Just one of them. because they're doing the same thing, so it doesn't really matter, I suppose.
Yes, remote repairs are harder to do, but it's still it's fun because you've got someone new like me learning this because all the information Joe is saying makes sense and it sinks.
Hey, if it made sense, it'd be fixed by now.
No. Hey! You remember what this is, right? It isn't actually Apple III, right?
It's
Aren't,
that's
aren't,
right.
aren't, aren't you the one that said that you got to pick it up at about 5 feet and then actually drop it?
You got to drop it to make it work. Yeah. Do it on stream. No.
And you gotta make sure of that because all the chips used to pop out when they got too hot.
Mm-hmm.
Okay. Dropping it pushes them back in.
Exactly.
All right. Okay. So 244 is in.
Good. Kick it back on.
Okay.
Cool. Great. Check pins 1 and 19 on the 244 again.
Nothing.
But they're low.
Yeah.
They're not high. Check pin 2 on the 244.
High.
Why would that do that? Is the ROM out of it?
Yes.
Okay.
And pin 2 is a 0, so it should be going to 9.
Mm-hmm.
But as soon as that's in,
why would that drive? You don't have this is I'm sorry to ask the asinine question. Ship's not in backwards, is it?
No, it's incorrectly. I mean,
notches fire if it was.
Notches forward this way, same as all the other ones.
There is no way on Earth that Chip can just hold those lines.
Let's do something here for 1 minute.
Now, it could be something else. Let's assume this is a red herring. Let's assume that's not our problem. Do you have 257s?
S257s? I don't know. I don't think I got those.
Okay, that's fine. Do you have
No,
LS 257s?
Not the 257s, but I can take the ones off of my other board.
Okay. Or we can take the ones out of this, just remove them from this board too, right?
Yeah.
Okay.
I mean, I have. No, I don't have 257s. The highest I got was S175.
That's fine.
I couldn't find any, so that's why I didn't buy them.
Video select just a multiplay. That's fine. I just want to look at it's AB, yeah, standard. Either picks this or that, and they're using it to some sort of address decoding BS. Okay, that's fine. I love how this just goes to nothing right here. Okay, stand by. So pull out D8, the 257 at D8.
D8?
D8. David 8.
Yeah.
Good question, Trina. What do you mean by a pull-up? A pull-up or a pull-down is a term used in computer technology to refer to something that ensures that the default state of a wire, a line, a trace, whatever, is a specific voltage. So a pull-up usually means it pulls it up to a logic 1. It's usually a high-value resistor. And a pull down is again the same thing, but it pulls it to logic 0, which is usually 0 volts or ground. And that helps to ensure that lines have a default state instead of floating around and moving around and stuff. It also, yeah, I'll just put it that way. folks are saying we need to check for shorts in the sockets and stuff. So that's the thing. I mean, we can do.
That's what I was just doing here. Hold on 1 second here. Let me. Because some were saying check actually the bottom of the board and that, and where the socket joins in. And that's where I was just going to. Give me 1 second here. I gotta straighten this up better.
Take time. Yeah, I see some trace repair and stuff on the bottom there too.
No, I haven't had to fix anything on the bottom.
I saw right there by your thumb or whatever. There's some red lines there. What are or is that a
No,
mark?
well, that's the red lines that I marked for the
Oh,
for the chips, so that I know to test them. Okay, here's pin 1, 2, 3. Oh, sorry. How is y'all's focus? Let me.
Yeah, it's close enough. You can see it.
Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay.
Then we go up here. There's 11.
Oh, that's is that the 257 you're looking at?
This is actually a 244.
Okay. Yeah, there's no obvious stuff on the bottom. Okay.
Okay, that's the 244. The 257 is the one right below it, which is going to be this one here. Now, this one here is actually original. That socket has not been changed.
Okay.
Okay, so this is still original.
Yeah.
Okay, that's the first 257. That's the one at position 7.
Okay.
And position 8 is going to be this one. Is going to be this one here.
Yeah.
Yeah, starting here. And that is still actually original also. And I don't really see any trace damage.
Yeah, and yeah, I don't see trace damage either. There's some weird possibility could be some funky short under the 244 socket. But like the only way you're going to find that out is to do an exhaustive pin-to-pin check.
Now, if we check it from the top, all right, this is the 257 This is the 257 we just took out.
Yeah. I mean, it doesn't look great, but
I don't see anything broken anywhere around there. This is the 257 that's still in. And then the 244.
Those traces are shiny on the top. Are they shiny because they're bare?
Those there, it could be.
Okay. I'm wondering if we need to check that socket for shorts in between pins. I doubt that's going to be the case because if there were shorts between the pins, it'd probably be affecting it whether that chip was in there or not. But if there's a short between both sides of it, between the input and the output side. Yeah. Thomas Armstrong asking, why have the sockets been changed? That's a good question.
Because some of them looked very bad and had feces and that in them from. So that's where some of these were changed.
You're doing an exhaustive pin by pin short check now?
Yeah.
I'm going to take a short break. I'll be right back.
Okay. Yeah, I don't see nothing here. I don't see no short.
Okay. I'll be back in about 60 seconds.
All right. Thomas, do you want me to back up the... Is that what you want to see, Thomas? That's as far out as I can zoom out. Thomas, which actually traces? You may want to check the traces back. Oh, you mean check them back to the actual CPU? I mean, yeah, I can do that. That shouldn't be too difficult to do.
Yeah, let's. That's a good suggestion, just to make sure that each of those go only in exactly where they're supposed to go. Pin 2 of the 244 should only connect to the CPU and to the ROM chip, and to literally nothing else.
Okay, pin 9, and on the CPU, it's which one? Sorry, on the ROM, it's 8, right?
And on the ROM, it's 8, yes.
Okay, good.
Okay. So next, you would check pin 4.
Okay.
Hold on. Rudy wants me to do something special on stream.
Okay.
My button's not working, Rudy.
Oh, what's it going to be? Thingamaboo?
Yeah, but my button's... Oh, wait, hold on. I'm on my StreamYard. I can do it this way.
Thingamaboo.
There you go, guys. Okay.
Okay,
Yeah,
so pin 4 goes to
Yeah.
9 on the CPU, on the ROM.
Yes. Sorry, I got distracted. Yeah, pin 4 goes to 10 on the CPU and 7 on the ROM.
Okay, well, there is 7.
Okay.
And there's 10.
Okay. It's not connecting to anything else on the CPU. I thought I heard it beep earlier.
It's only beeping one actually spot.
I thought I heard it beep like right there at the front of the CPU. Okay, I must be hearing it wrong. Okay, that's fine. All right, cool. There might be a slight audio delay too. That's fine. Okay, so pin 6 of the 244 should go to 11 of the CPU and 6 of the ROM. You can probably guess the pattern we got going here. Okay, and then it's 8 going to 12 and 5.
12, 5.
Okay. Now we change the pattern that we're using on the LS244. We're going to go to pin 11.
11.
Yeah. It goes to pin 13 on the CPU.
13 and 4.
And 4.
Okay.
The next one is 13 on the 244.
3 on the CPU and
3 on the ROM.
Yeah, sorry, 3 on the ROM.
Yep. And 14 on the CPU. And then it's 15 and 15. And 2. And then 17, 16, and 1.
We're good.
Yeah, so that's fine. I didn't think that would be the problem. Yes, Bob Darlington, only one light soundboard is left in stock at jcm-1.com. So if you want a light soundboard for your Apple IIGS to give your Apple IIGS stereo audio, you got one chance left. You better run and get it now or they're going to be gone.
Now, Flint, if you say that you're still awake, yeah, because I remember you telling me you have a hard time sleeping sometimes. So mean, UK time for you, geez, what time is it over there now? It's 9:40 here, so add
It's
5 hours,
9
6
plus
hours.
5, yeah.
Oof,
Yeah.
2 o'clock
2
there
in the
for you.
morning. 2:41 in the morning. Ugh.
Flint is a fellow actually collector, actually a restorer over there in actually UK,
Cool.
and we talk a lot. So, and he does well.
Flint, get on a plane and get over here and help us fix this thing.
He's more into the PC side though, not too much on the Apple as far as
PCs are boring.
I
I'm kidding. No, they are very fascinating. They have
I
their
will
own.
let him state which ones he's more into. So
It's all good.
okay, so the 244 I know going good there. I mean, but
Okay,
then
so yeah, we've got that there. Stand by.
I mean I really can't see where the 257's impact. And this is still with the other CPU.
Yes. So we know it's not the processor, and we know it's not the 244 specifically, unless you have another bad 244.
I put back in the actually original one, so that's what's in right now.
I don't think that's the issue. I think it's just helping the problem present itself somehow. I don't know how though. If you put, I know we've already tried this. If you put the ROM back in, you probably get the same thing, right?
I can try it. But I'm really wondering about this ROM with the socket because it sits in there so loose.
Yeah.
I mean, because look, I can pull it out with my fingers.
Yeah, I don't like that socket either.
So I think that tomorrow during the day I'm gonna swap this socket around.
Yeah. You can also do the whole thing of like pressing down on it really hard while turning the computer on. But yeah.
I was trying that a few times when I was turning it on.
Rudy's asking, do we have an IC tester? We have a what do you want to call it? You have a chip reader, and we read the ROM, and the ROM gets the right checksum. It matches the checksum that comes from my machine. Now, which chip reader do you have? Do you have the XG Pro, the TLS 866 Plus?
Yeah, the same one.
In theory, you can test a lot of logic chips with that.
Yeah.
So we may be able
I have tested just about every single LS on this board with it.
And they're all fine. Okay.
Yeah.
All right.
So I've already done that part, yes.
Okay.
Okay, you see, that's what I'm getting again.
Okay.
But I got a little bit of pattern. I mean,
yeah. Hold down on that ROM chip like crazy. And you got a slightly different pattern that time. Interesting. Why would the ROM not being there cause that? Okay. I have another suggestion. You can try, how can we put it? Twisting the ROM, like literally like just doing that to it or that to it to try to give it a little bit of a tension in a specific direction.
That's one direction.
Okay. Pattern's different?
It's about the same.
Oh, okay.
In either direction that I go. And if I just push down, it's the same. Yeah.
Okay. It's a little hard for me to tell.
But I want to see if I have anything on.
Yeah, let's see if we got wiggles. Wiggles!
Okay, I'm off on 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm getting that. I'm getting a little bit of. I'm getting something strange there.
Yeah, it's like it's kind of.
Oh, wait a minute. No. That's my fault. Sorry. I don't have the ground connected.
Oh, yeah, do that. Grounded doodles.
high.
It's just high all the time. Okay, so the ROM doesn't have a direct effect on it. Okay. If you don't ground, you still get some. Okay. My thought would be to replace the LS244 socket in the ROM socket with dual wipes.
Okay.
That also gives the opportunity to see if there's something just funky going on.
Mm-hmm.
So that would be my next step. Because we're not getting, gosh, it's got to be something with that 244. I'm just, you think about it, the inhibit lines coming in, or the enable lines, E1 and E2, which are pins 1 and 19, coming into the 244 are correct. They're correct all the time.
Yeah.
The 257s, are those accessible?
Oh, shoot. You know why the thing, one of those 257s is not in right now?
Okay. Well, let's put it back in. Yeah. C10 drives the ready pin to the CPU. Yeah, Mike Rojas is doing some checks in the background.
C10 for me is a custom chip. C10 is a 3410043. It's a custom chip.
Okay. Well, we'll get to that in a second. I want to. Yeah, ready should be high.
Okay, memory's back in.
Okay.
Okay, there's the pattern. Sorry, I moved it closer because I had to, when we were working with the.
Oh, that's fine. We can see it. That's cool. Yeah, check the ready pin on the CPU, pin 2. It should be high.
Yeah, it's high, but it's as high with some noise.
I'm not too worried about the noise so much. I mean, it depends on what it's just like tiny little itty bits of noise.
Yeah, I mean, you can see what it's doing up there.
Yeah, that's just noise. That doesn't matter. So that's high all the time. It's not wiggling.
Yeah.
Okay, so I'm not worried about that then. Yeah, Mike, I'm pretty sure we had checked the ready line pretty early on in the stream, but that is a good thing to check. No wiggles on the address lines.
9, nothing. 10. No, high.
I would put in a load
11
on the
high.
CPU line.
12 high. 13 high.
Cause the CPU to halt.
They're all going high. They're all high.
Disconnects this and this. If that's driving, that might pull them up, but that's it shouldn't drive the other direction. It's a one-directional chip.
I'm gonna try something here. I don't know if this will make any sense, but
so
I'm gonna borrow the ROM from the other machine.
Okay, you can do that. It should be identical. I'll try state octal buffer line driver. And see, it's a unidirectional part. It goes one way.
Yeah, I just don't like how easy this ROM pops out.
Yeah. Agreed.
You see, that one goes in way too easy also. Same thing.
Just spin the pins out at 90-degree angles. It'll really go in now.
You see, when I'm pushing down real hard, you see how different it looks?
Yeah.
It's completely different.
Well, that's definitely going to be part of the problem.
Yeah, I'm definitely going to switch those around. I had to move them around because some in this area here, it was very dirty and a lot of corrosion and that. So I really had to clean it good. And I didn't like how the old sockets looked. They looked very black.
Yeah. I'm going to say that we're going to want to, at the very least, replace that socket to eliminate variables. I'm not 100% convinced that has everything to do with the problem.
All right. Well, the ones that has the actually machine sockets is the ROM, the CPU, and that 244 has it also.
I'd be replacing those sockets and putting dual wipes in there. While you're at it, checking to make sure that all the lines connect to the pins and all of that stuff, and then UV solder masking to isolate stuff.
Okay, now I did have. I'm off, right? Yeah, I did have one chip over here that I had to do. Wrong one. I had to do. It's a LS133 over here.
Okay.
I had to amputate an old chip and borrow its legs and solder them onto this one.
Okay.
But this chip here still looks pretty yucky.
Yeah.
I think I have new 133s.
Is the socket new?
I don't have new 133s. I couldn't buy those.
Okay.
I have 132s and then 138s. It doesn't go to. I don't have 133s.
Rudy's like, I'm guessing no diagnostic ROM for the Apple III. It does have a built-in diagnostic ROM, Rudy. It's fairly rudimentary, but it's not even getting to the point to where it runs code. Like the CPU isn't even running.
And I don't need the keyboard for any of this. No, because we haven't gotten to the point where it even fires up the keyboard yet.
Yeah, if all the Apple III will do with the keyboard removed is run the diagnostic ROM. The diagnostic code. Yeah.
What does that look so bad? No, it's just brown.
I'm going to show the schematic here. So this is why I'm so perplexed, because this is the 3410031, which is the ROM, right? And the address lines we're seeing on the 6502, the processor, which is right here, the ones that we're testing, which are A0 through A7, the least significant 8 bits of the address. When the ROM is in, they wiggle like it's trying to run code but can't. And that's fine. When this 244 is in, they all go high and the CPU just freezes. And that doesn't make sense to me. Like, how would this have anything to do with these address lines not doing anything? Because the LS44 drives out. These are inputs to the 44. These shouldn't be doing anything to those address lines at all. That's like the whole point. They're high impedance, so to speak, in reference to this, because this is a driver, because it comes in here and goes out there. Whether this chip is in or out or not, both of these pins are driven correctly. So that's not a problem. It's almost like, a short under the socket of 244. It's like when you plug the chip in, it somehow is shorting all these pins to 5 volts. Somehow. But only when you plug the chip in. It's really weird.
And I don't think it was a bad 244. I can try another one again and see, but
unless the outputs of the 244 drives other circuitry that returns to the CPU via ready, I suppose that's possible. But this is just the address. This is the outgoing address from the CPU going through a buffer. I'm not. How can I put it? I'm not 100% certain that it wouldn't happen, but I'm pretty certain that the CPU would not drive its own ready line low. It could, in theory. Maybe it drives its own ready line low. But here's what we're seeing, though, is that when the CPU is frozen, when all of the address lines are pulled high, and the CPU is locked when we put that 244 in, the ready is high anyway. Ready is not being driven low by anything. It's just high all the time. So the ready line is a red herring, Mike. I'm pretty sure. Search back here. Mm-hmm.
I put in a different 244, and it's doing the same thing.
Mm-hmm. We need a NOP generator. Yeah, agreed.
I mean, it don't matter what 244 I put in there; it does the same thing.
Mm-hmm. That's great. A NOP generator. I just got an idea of like a really cool diagnostic tool that you can just plug into the socket with. You plug it into your socket, then plug the 6502 into it, and it'll just generate NOPs.
You see,
Anyway.
when I don't have it in there, look.
That is so weird. And it's trying to run. But of course it doesn't run correctly because it doesn't have access to the rest of the bus.
Unless the plus is doing something different. Because remember, we're going with schematics of a 3.
This is true. However, it is my understanding that electrically the plus is identical. The only difference is the board layout.
And the actually external floppy connector.
Yeah. The 144 is out of the machine, right?
Yes, right here. Socket is empty.
What's the output? What's the value on pin 3?
Pin 3, kind of floating.
Floating. Okay, that makes sense. So it's not being driven. And 1 or 19 are both low.
1 is low, 19 is low.
Okay. So that means that the LSO4 feeding it to enable
correctly.
It low.
Well, it's high, but it's sending out low. Yes, okay. It's doing the opposite.
Pin 3 on it comes in high, and then pin 4 goes out low. Of the LSO4, correct?
So is the CP is the ROM impacting it any?
If the ROM, yeah, see,
there too now. You see, here it's telling me that the ROM with the socket is actually good because look.
Yeah, we're getting wiggle.
So it's not the socket. I mean, if I go now and check every single address line, they actually start at 9, right? 1, 2, 3, 4, 5, 6.
Addresses
7,
go
8,
from
9.
9 to 16, or at least.
Okay, look, 9, 10, 11, 12, 13, 14, 15, 16. Everything is perfect.
Mm-hmm. With the 244 removed.
Yes. And 244 is only getting...
So none of that matters.
Those other lines are going out of it, right? That 18, 16, 14, 12, those are all outs from it. Okay.
Yes, and they're all just floating.
Okay, so that's everything going out. So the only thing coming into that
is pins 1 and 19.
1 and 19, and then the ones from the CPU, which we just looked at, and they're all there.
Right. I'm trying to think if.
Let me check the ROM if they're all there. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. There we are. You see, we're getting that. 7, 6, 5, 4, 3, 2, 1.
Yeah.
That socket is fine with the ROM.
Right. So, is the CPU getting data on its data lines 26 through 32?
All right,
Or 33?
meter from there. All right, let me put it there.
Yep.
26, 27. You can see it, right?
Yep.
28, 29, 30, 31, 32.
Okay, so it's doing something. It's getting stuff. Whether it's getting the right stuff is a different question, but we can figure that out in a minute.
I wonder how which one is the clocks again?
Clock is 37.
40, 39, 38, 37.
Yep, so that's working. Okay. The rest of those shouldn't matter. And we already checked all the IRQ lines. And those are all high, so that's not a problem. Pin 40 should be high. So should pins 2, 4, and 6.
40 is high. 2, 4, 4, yeah. 6, yeah, they're all high.
So yeah, that's all fine.
2 if you're ready.
Yeah. Acid rain, could it be a bad video sync? Oh no. We are getting a locked raster on the monitor. It's not a sync problem. Okay. The 8304 can't sync.
You see, so without that 244, the CPU is firing, ROM is firing.
Yeah.
I mean, 257s, am I supposed to have anything on them? Or, I mean,
in theory, really, yeah, because the 257s are the high part of the address bus. So that's involved in like bank switching and.
Okay, so D8, pin 4 here. 1, 2, 3, 4. Yes, I got signal. 4.
So, and then the next one
5, 6, 7. I got signal. Next one will be 9. 8, 9. Yes, got signal. Although not too good, but it's there. You see what it's doing, but
yeah, that would be you would be getting like random crashing and stuff. It'd be starting and stopping and starting and stopping and doing wacky stuff like that, not just a solid pattern if that were the problem. Okay, and then 12.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Yeah, there it is.
So that's the out. Those are the output sides of that. Let's check pin 2. Yeah, pin 6.
4, 5, 6. There's 6.
Pin 11.
11.
Pin 13.
11 is high.
I'm sorry, not 11. 13. 10 and pin 10 and 13. I said a thing I was looking at instead of the thing I should.
Yeah, okay, there's 13.
Okay, cool. And then on the other chip, again, it would be the same inputs.
So the inputs are 2?
The inputs are 3.
3, yeah.
6.
Yep.
10.
Yep.
13.
Yep.
Okay, so the inputs there, the outputs of that one are going to be 4, 7, 9, and 12.
4, 7.
Yep.
9, 12. Yeah,
all the same. I don't think it says. I don't think it says.
Yeah.
And I'll bet you put the 244 back in, that'll all flatline again.
Yeah, I bet you that too.
I would be checking that socket. I'd be yanking that socket out, checking every trace, every via around it,
Well, I
isolating it
got an
all.
option. I can do it now on the air, or I can do it during the day. I don't know how people are feeling.
Well, we got 30 people watching, which is more than we did when we started. So we
All
might as
right.
well just, if you've got time, I got a little more time. Just yank it out,
Okay.
man.
Let me yank it out.
We now have 31 watching. We said we're going to do a live repair, and they're like, yeah.
Well, this is a pretty good live for repair though, because I mean we're all being challenged here, and I love the input from people. So
Yeah, we had a lot of good suggestions from folks. I'll make you big so people can actually see it. Mike Rojas. I like Mike Rojas's suggestion knob generator. That makes me think, like, is there a little plug-in circuit we could make that would go into a 6502 socket, where you plug that into your computer socket, then plug the 6502 into it, and it forces the 6502 to generate knobs? That would be really neat. What would be really helpful would be a Fluke 9010A, because we could plug that right into the CPU socket of the Apple III and do a ton of bus tests, tons of awesome bus tests with that machine. I've been looking for one. There was one on eBay. It was expensive. I decided not to buy it, and then somebody else bought it. I'm like, crap. Anyway. Doobie doobie doo. Doobie doobie doobie. Do, 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 do. Ooh, yep. Justin's show. There you go. A knot tester right there. Mm-hmm. Yep. Are you going to use your cool hot air method to yank that out?
no,
Okay.
no, I wasn't going to, because I don't like to use too much hot air on these delicate boards.
Yeah, those older boards, they're really susceptible to delamination.
Yeah.
Ask me how I know, Franklin
Oh,
2200A.
you got to ask me the same thing too. Okay, where did my tweezers go?
For like 2 months. Go back in here, Apple III. You can do it. There we go. I was going to go to bench cam and take apart a thing. Oh, you do that?
Well, I mean, remember we talked about it. If you want to let anyone else in too, that's fine.
Yeah. Does anybody else want any of our viewers really want to hop in and give their 2 cents live on stream? We'll give it out to the patrons first, and then my patrons go over to the Discord and say, Joe, give me the link, and I'll pop the link in there if you want to hop in and do the thing. Or it just be like comic relief in the background. Hey guys, Mark's in Canada. Good work so far. Let's see the new socket put in. Yes. And
Yeah,
Adrian
Mark
Black
is.
in that tester too. Yeah. Casterly Rock Developments. My only question: did you put a longbow bolt or a crossbow bolt through your dad's heart? Haha! Game of Thrones joke.
See, with these boards, I'm so delicate. I don't like to use a lot of heat.
Yeah.
And I'm being extra careful.
Yeah, you have to. Doing the solder wick process can take a really long time, but it is kind of the most delicate and gentle way you can do it, because you're way less likely to pull a trace or pull a via or anything like that. So
yeah. I hope I'm staying in camera for y'all to see.
Oh yeah, you're fine.
Is it focused okay too?
Oh yeah, I think it looks great. Acid rain, how much heat? Good question. What do you run your solder at? Your iron at?
Mine right now is at 320.
320 Celsius?
Celsius.
I was going to say 320 Fahrenheit would probably not be high enough. Now I've got the Game of Thrones music stuck in my head. Do 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 do.
Yeah, we got. I mean, shoot, 30-some people watching. That's a pretty good number
Yeah, that's. Sorry, I'm across the shop. Hold on.
for an actually Tuesday night.
Well, when you put up something like "Can we fix it?" everybody's like, they're here for the challenge. I just ran across my shop to just get a wet towel here. I'm cleaning off glue stick. Oh, Zodium is here. As a matter of fact, Zodium can probably see me working on something for him.
No, sorry, I'm not reading the messages. I don't know.
That's fine. I'm watching him.
Yeah. So no one wants to join in.
Well, Zodium says he will. I just popped it in the my Discord, so or my patron Discord. Bye, Frank S. It's a cliffhanger. Yeah.
Yeah, there might be a part 2 to this, but I'm hoping there's no part 3.
We shall see. We shall see. Which is the painted surface? That one. None of them. Because that one I did this way. Yeah. Just this surface right here. Boop. Boop. And boop. Cool. Oh my gosh. Who's this? Who's in the background? Who are you? What are you doing?
I don't know. I was just told by some crazy guy to show up here.
Hey, Zodium.
Crazy!
Hey, Will.
One final thought. Smash that like button. Yes, hit the like button, everybody who's watching. If you've had fun watching us like fiddle about and try to make this thing work, hit the like button. Shows the YouTube that you like my stuff, or in this case, Will's stuff, and it will start to show that stuff to people who like other things like my stuff.
Well, those of you that are not sub to my channel, go and hit that.
Go freaking
go
sub
hit
to his
that sub
channel. As a
button.
matter of fact, I am going to go get your channel link and I'm going to put it on the screen. And I expect your sub rate to increase.
to actually go up.
I'm going to go click that button and go find your channel. And there's your channel. And there it is. Go subscribe to CayMac Vintage. He is doing shorts and videos and live streams and stuff all the time. Fixing.
I'm not doing too much right
SE30s.
now because I'm waiting on my cargo to arrive.
Yes, it's been about 10 days or so since you did something.
More than that, but living on an island, you really have to. You don't get stuff as much as just walking down the street and buying it.
Yes. Those who might not know, who are my followers, but not necessarily CayMac's followers. His name is CayMac because he's on the Cayman Islands, down where it's warm and sunny and not cold and freaking snowing right now. So super awesome sauce. And of course, we have Zodium here, who's our wonderful friend from multiple different places, who is in California. So it's also
we're underwater.
Oh, that's right. You're being like totally cinema. What is that? Will, what's that on the board right there? Right there. Up. That little line. What is that? Is that like just like a
This is a piece of hair from the brush.
Okay. Just want to make sure that
I get those all over the place, so I'm just wanna come back and make sure I got everything out.
I will be right back. I have to reboot because my PC is being very dumb right now.
Yeah, sounds like me. Okay. We'll see you when you're back.
I'll be back.
Yeah, Zodium had this picture he sent of me. Here, I'll see if I can show it. Yeah.
Okay, now I do gotta use some actually heat because the rest of the solder is on the underside of the socket.
Yeah. Oh, just pull on it really hard. It won't.
You want me to pull those traces out on the other side?
Yes. No, I'm kidding. Don't do that. Javier's here. Hey, Jav. How you doing, buddy? We got 3/4 of Retro Repair Roundup here in the chat. I'm surprised
Wow.
Rudy is still here, actually. Rudy is usually
Flint,
so
Flint is
busy
still
with
here
work.
too.
What's that?
Flint is still in.
Hello, Flint. You still here, buddy?
That's the one from actually UK.
Yes, it's like middle of night there.
Well, he doesn't sleep, so
He doesn't sleep. Sounds like me. Shh! Don't tell my employer. No, I got up at a normal hour today. I got a lot of work done today.
sorry, my view is kind of out right now because the board tilted up and heat and that. It's kind of hard to show that on camera.
It's all good.
Only reason why I'm using air now is because there is some solder stuck on the other side of the board holding the pins in, and I can't get that out with the wick. So,
John Wick. He killed a man with a pencil. Oh my gosh, Justin E. Morgan. What are you doing, buddy?
Trying to find my mouse cursor.
You're
You'll
in
see
DOS,
why in a
there's-
moment. Did someone ask for comic relief?
Yes! Now,
I found-
you are now required to shake your head back and forth at a high frequency constantly.
Oh, no, I better not do that because I'll get
Oh,
dizzy.
okay. You'll
all
get
right.
brain damage.
All right. So here is the top side of it.
Yeah.
Let me try to clean it a little bit. And
Error
Weird.
reading.
I mean, it looks fine to me.
okay, so I mean, I can zoom in a bit more. You can see it better, but there.
That's good right about there. Yeah.
Okay, I mean, I don't think any of these traces look bad. I mean, even though this right here looks somewhat dark, it's not
Yeah.
really.
I think
mean,
that trace is fine.
That's fine because it's just how this solder mask is.
Yeah.
Okay, and all of these are very nice and shiny and clean.
Yeah, the pads, those pads there, top left, look a little weird. Why do they have that circle around them?
That is solder. I gotta go clean that off right now.
Oh,
Give me-
okay.
Give me a second here, and I was seeing that also.
Yeah, that's fine. Yeah, the scope view that you get through the live stream doesn't always like give you the proper view because you don't get a 3-dimensional view.
Yeah, I
Is
tell
your
you
computer working now, Zodium, or is it like me where it's at 100% at all times for absolutely no reason?
I'm kind of hoping and praying that my capture card didn't just blow up on me because Windows has decided it's no longer going to recognize it.
Oh no! Oh no!
Yeah, it's an Elgato card, so it isn't cheap
Third
either.
pad in bottom right. Is that connected to that trace?
where?
The third via in bottom right.
This one?
No, the next one to the left. There's like a little one over to the right. That one. There's like a little. It looks a little weird there.
Yeah, let me finish cleaning this and I'll check it.
Okay. TJ's here. Hi, TJ. Celtic. Is it Celtic or Celtic? Whichever one you like to say.
Yay, through punching it enough times, it came back to life.
Literally punching it.
No, I reconnected it and disconnected it enough times, and Windows finally sorted out its whatever fit it was having and started working again. So,
Joe, you're saying this one?
Yeah, it just looked like it was. Yeah.
Yeah, it's fine.
Oh, okay. Cool.
Is that right?
Yeah.
1, 2.
It could be like my computer, Zodium, where for no reason my CPU is at 100% at all times. It's
so
not.
that Photoshop I did of you wasn't exactly inaccurate.
No, it was pretty close. Something happened with the Windows update, and it's just wrong. Like,
Are you running 10 or 11?
10?
Yeah, see, I think a lot of my problems can be attributed to the fact that I'm dumb and I took the 11 update.
I'm laughing at you. Sorry.
Okay. No, I'm like the problem is I had a lot of people asking me like, "Hey, how do I do this in Windows 11?" or "What's your opinion on Windows 11?" And I started realizing I have no idea what Windows 11 is because I don't use it. So I'm like, I need to start learning it
Yeah,
because
don't
people
worry,
are
I don't
gonna.
think Microsoft's developers even know what 11 is, so that's fine. You're in good company.
Microsoft's developers be like, I thought we were done with 10.
Rudy is saying, since the sock is out, test these trace. I believe that's what you're doing, right, Will?
That's what I was doing. Yeah, that's what I'm. Do you see any on this bottom side you want me to check?
Yeah, I mean, just check them all anyway, just in case. Tom, I love your last name, Tom. I'm not going to try to pronounce it. What are you fixing? We are attempting to fix an Apple III Plus that has got demons. It's got like Sean from Action Retro demons. So
I know this is a tough job because just early on, Joe just like going full like closed eyes, like just full Zen mode, trying to figure out what to even where to
because it
even
doesn't
go.
make any sense. We plug in a chip who only has inputs, not outputs, only inputs connected to the CPU, and it hangs the CPU. Figure that one out.
Anyone see anything you want me to check in that before I go put this socket in?
Just, I mean, making sure all the traces have connections and also making sure there's no obvious shorts between pins.
Yeah, well, that's what I keep on checking here. I don't really see anything. I mean, on the other side, there's a lot of shine. I mean, I can put solder mask on it. I mean,
Yeah, usually what I would be doing is putting solder mask on the back side there, probably not as important. But on the top side, absolutely. Especially with that round pin socket, because what can happen is the bottom of that round, you're not going to be using a round pin socket.
no.
obviously.
I'm gonna use the
But
other sockets.
the round pin sockets have that big fat lug on the bottom of them
Yeah.
that can pull up solder and cross connect to other pins.
Okay. Well, I'll
that's
throw
been
some solder mask on this thing.
yeah. So that would be one of my suggestions. Mike is saying is a bad decoupling cap. Could be. I don't think so, based on the behavior, but it could be.
A bad what?
A bad decoupling cap. So in the vicinity of that chip, there might be a small 100 nanofarad or a 0.1 microfarad capacitor that you could check for shorts.
Mm-hmm.
Not pants, shorts. Very important. Get it? Get my joke? Ha ha ha! Laugh.
I see Luke is in here watching. Luke actually lives here in Cayman. He's a younger
Hi, Luke.
person that is into actually retro computers.
Cool.
He bought two machines from me. So
Welcome to one of us. One of us. I'm doing this thing in the background. You can't see me. I'm doing this. One of us.
he's bought an actually for me and also a 2C.
Cool. Apple II forever. Tom, again, I'm just going to call you Tom. I'm not going to try to butcher your last name. Tom, what happened to the solder mask? Very good question. So,
It's coming.
yeah, the Apple, I think he's asking what happened. Where is it? Like, how did it go away? When you do a lot of work on these older boards, especially the Apple III, they did a very cheap, almost like lacquer kind of solder mask and not a plastic solder mask. So what happens is when you heat it up, it just flakes off and goes away.
Well, you see, this is why I had to use a round pin socket. I don't have any 20 pin.
So take a 24 pin or something and cut the end off of it.
Yeah, I've got 24 I can use.
Yeah. So yeah, you can take a longer socket and cut the pins off the far end. You can actually, in theory, even just take the pins out. You just pull them out through the top
Mm-hmm.
and just leave the whole plastic socket in there. As long as it'll physically fit in there and it'll clear other chips around it, you can do that. I can show you. I can demonstrate.
Yeah, I know what you mean by it.
Well, I'm going to demonstrate for the people on the stream.
Go ahead and do that while I put the solder mask on.
So if I do this thing,
because I got solder mask I need to go put on.
Is my scope? Oh my gosh, my scope's actually working for once. So that's actually that's a good one to do that with. So let's. Am I actually? Oh my gosh, it's also in focus. It's a friggin' miracle.
Wow.
So say you've got a socket like this, but it's got too many pins. Dual white sockets they're just this basically spring steel stuff pushed down through a hole in the socket. So you can actually just grab a hold of it. This might not be the right tool to do it, but you can just pull the pin out and leave a hole. So say you wanted to use the socket for that, you could literally just do that. Just pull the extra pins out. Do it. Get in there. Get in there. Get in there, I said. Do it or else. Pull them right out. You just come out. Yep. And so that's a kind of a quick triage thing. And then you don't have to worry about cutting this plastic here and then accidentally cutting too far and messing up the socket and having to do another socket and all that stuff. So.
Sure.
Yep. Mm-hmm. This next thing that Will is doing is replacing the solder mask. For those who don't know about that, this is special stuff. It's basically UV cured solder mask. It's this weird polymer cross-link stuff that when you hit it with ultraviolet light, it cross-links the plastic and it becomes solid. And it helps isolate the stuff from each other. It also helps prevent the traces from reoxidizing, rusting, corroding, whatever you want to call it, from simple air. It does magic things. And now, an ode to my cat, Spot. Felis catus. Get it? Star Trek joke. Felis catus. No. Okay. Zodium got it.
I didn't get it. I'm just like laughing at the way you're saying it.
Ode to Spot.
I'm trying to get something stupidly simple to install on my 486, and it's not working.
Felis catus is your taxonomic nomenclature, an endothermic quadruped, carnivorous by nature. Your visual, olfactory, and auditory senses contribute to your hunting skills and natural defenses. I find myself intrigued by your subvocal oscillations, a singular development of cat communications that obviates your basic hedonistic predilection for a rhythmic stroking of your fur to demonstrate affection. A tail is quite essential for your acrobatic talents. You would not be so agile if you lacked its counterbalance. And when not being utilized to aid in locomotion, it often serves to illustrate the state of your emotion. O Spot, the complex levels of behavior you display connote a fairly well-developed cognitive array. And though you are not sentient, Spot, and do not comprehend, I nonetheless consider you a true and valued friend. Good question, Rudy. Rudy is asking, can you use nail polish? You can. Nail polish will work in a pinch. The upside with nail polish is that it will cure itself. The downside is that it cures really fast. So you usually end up just drying out your nail polish, or hardening your nail polish that you use, and you have to replace the nail polish frequently. The upside is nail polish is cheap as heck. So you just literally get the cheapest nail polish at Walmart you can get. The color you can try to get green or clear, but yeah. Bob Darlington sees a broken trace. Where, buddy? Where do you see it?
And this is why you do things live, because you got multiple sets of eyes.
Oh, Joe, you want pink nails. I mean, boards.
Yes.
I just want DOS to install.
Across the white stripe is what he says.
Here?
Yeah, that does kind of look suspicious there.
I would just go ahead and double check all those down, he says.
This one here is good. This one is good. This one is good.
That stripe going right between that one right there. Check that one.
Good to there. I mean, good to there.
So it's good across the. Okay. All right. He says to the left. So to the left of that one you just tested.
To the left of this one. This one
so
is
that
fine.
One, that one that goes between the pins. Yeah.
This one here.
Yep.
Good.
Okay, cool. Thanks for checking that, Bob. We appreciate that. Bob, if anybody doesn't know, is the designer of the light sound board, which there may still be one left at jcm-1.com. There may not. It looks like there is still one left. Just one. My website hasn't told me it's out of stock yet. One left, all products. Clicking, and then I go to filter by stock status, out of stock, filter.
And it says bluish scuzzy out.
Yes.
Why? Because I bought them all.
You're out of blue scuzzies already, Joe?
Oh
Wow.
no, I don't.
No. It's a joke.
I don't think I have plenty. It's got stock for days, buddy.
Luke was supposed to order some from you for the actually power book. I don't know if his father ordered them for him yet, but
that's a good question.
he was.
I was thinking of ordering them until I got my power bill. My power bill was up.
Oh, Luke was one who bought 4 of them. Yes, I remember the 4 orders.
And
I remember because I packed one and I'm like, you need more than that.
I think 2 of them were actually for me that he bought because I asked him to actually pick up some for me.
Yes.
Since he was doing the order.
But Bob does the light sounds. The coolest thing about Bob is this. He not only has seen old industry salt and knows lots of really cool people in the industry, and knows a lot about electronics and all of that.
All right.
He
Everyone
also
happy with that solder mask? That look good?
I mean, good enough as long as the pins you have to solder to are open.
Yeah, those are open.
Because you're going to be soldering from the bottom side anyway, so that should be fine. But Bob just bought himself his own pick and place machine. Yes, Bob can do his own at home pick and place of S&D components. It's nuts. So if you buy have bought one of the most recent batch of light sounds, those were built with a home brew pick and place machine. That's nuts. That's crazy. It's super awesome. Tom bought one of the Blue Scuzzies a few weeks ago. Didn't build it yet, though. Well, you're going to have a lot of fun building it.
I built all that I have from you, Joe. I've got 10 coming from actually Eric directly.
Cool.
5 internal and 5 external because he was having a very good sale on them, so I picked up 10 more.
Yeah, he was selling some of his leftover version 1 stock, I think.
So all I had to do was buy my own actually a blue pill, and I bought those. So
yeah.
Okay.
Eric is actually trying really hard to get out of selling them directly himself, because he wants to develop the product and let us vendors and people with like the soldering setup and all that do that, so that he can focus on the development side. Kind of a how do you want to put it, a division of labor type of thing. Rudy is asking, how do the top traces look? Well, we will flip the board over here in a little bit once these bottom we mean the bottom traces. He's doing the top traces now, Rudy.
So now I wonder if a blue SCSI will work with the Lisa with an actually, if it has an actually SCSI card.
If you get a Lisa with a SCSI card, it should work just fine. Yep.
Well, it doesn't have a SCSI card. I am making one that was developed. I put in a $500 order today with an actually PCB manufacturer. So,
how much UV curing does the solder mask need? That is a really good question. Until the solder mask isn't wet anymore, it'll become solid. you'll kind of see it get.
All right. Basically,
cloudy.
what I do is now I've had it on there for a bit, so I'll take a Q-tip and I will roll it over. And if I see any green, it's still a little bit wet.
Mhm.
You see, so I see some green still.
Mhm.
But sometimes if it's put on a bit too actually thick, that will take longer to actually cure.
Mhm.
And by doing that, actually Q-tip, rolling it, you don't want to rub it. If you roll it, it will now spread all over and it will clean up nicely. So I'm gonna cure this for a couple more seconds.
Adam McGee, a Lisa will not boot Lisa Us from a SCSI card. Well, that's good to know. Will it, Adam? I presume it will only boot it from a profile or a floppy.
Well, I've got someone developed a Arduino Nano, no Arduino Uno, one of those Arduino's boards with a hat on it that will emulate a profile. And supposedly it will boot. So I have that
That is
board
awesome.
coming and all the chips to actually make that.
That is super awesome.
I have the board coming to make actually my own actually SCSI and all the chips and everything that I need. I've already ordered.
Cool.
I've ordered 5 blank motherboards, 5 blank CPU boards, and 5 blank IO boards. So yes, I got $500 worth of stuff coming from a PCB maker.
Wait, did I?
Okay, so this side should be good now.
Ooh, Rudy has something coming out for the Naboo computer very, very soon. Rudy, if you need somebody to help you test whatever that is, you let
I have
me
a
know.
Naboo coming too. I have one to come, and I bought one a couple nights ago.
Dave's Vintage Apple Tech is here. Hi, Dave. How you doing?
Okay, so that side done. Now, who wanted to see the bottom side?
Rudy wanted to see. He said the top side, but I think he thought we were working on the bottom. So,
Okay, that's the bottom.
and as long as you're really careful with the solder, you
well,
shouldn't need to
I'm fine
remask
with
that.
that.
But I mean, you can remask it if you want. Bob Darlington, what's the pricing on the Naboo these days? I got mine when it was like $25, but I think they've come way up to like 100 or something.
119 I just paid, but that actually includes shipping.
What is going on?
And I think one of the reasons why he increased the price was to try to reduce the demand, because that first batch that he did when he opened it up, he got requests for 700 machines all at once, and he's like, "I'm one person." So yeah, my Naboo is right back there under that blue box. It's right there. I still have not opened mine.
I think I'll have the only one on the island.
You're special. Yeah, and they're also selling them only in the U.S. They're not doing it internationally. So if you're an international person and you want one, talk to somebody in the U.S. that you really, really, really like and have them get it for you.
Yeah, the only reason I can get mine is because I have a house in the States, so.
Cheater.
Ah, crap.
Who's doing rackety racket noises?
I took out the pins from the wrong side of the socket.
So put the socket in backwards. Who cares?
I don't want to do that.
I know you want the notch to match so you don't get.
Yes, because then next person will put in a chip backwards and fry it. No, anyway, it's all right.
That's not a gigantic solder ball right next to that chip, or is that a VIA?
Where?
Below and to the left of the 0043. Right there. Right there.
That is a VIA.
Okay, cool. Just the way it looked like it was bulbous, like it was a solder ball.
Yeah, that's a VIA.
You can't tell certain details when it's 2-dimensional when you're not looking.
Boy, I tell you, that was the weirdest thing when I went from an actually 2-dimensional scope to actually this one.
Mm-hmm.
It was the weirdest. It took me a while for me to get used to it.
Tom Gwatz. I tried to pronounce it. I failed. Tom, I got one because I thought it would be fun to do some reverse engineering, but most of it is already done. Me too. I got mine to do some reverse engineering and figured maybe I can develop something cool for it or do something. But I decided, because I am such a hard person to buy Christmas gifts for, I requested the RS422 as a Christmas gift. So that like delayed me working on the Naboo for about a month. And by time that delay went through, like the thing had been fully reverse engineered and adapters made and server software made, and well, we're done. So yeah. Ooh, Bob recently picked up a FujiNet for the 2C2GS that you need to find time to play with. Yes, I do want to make a small announcement about the FujiNet. I've been in I don't want to say talks. That sounds like it's something formal and special, but I have been communicating with the FujiNet team about becoming a FujiNet distributor on my website. So hopefully I will be able to have FujiNets available for the Apple II community. In addition, I'm also working with Peter Puskarik on the on the smart port capabilities of the Apple II to be able to have a smart port card that you can get in collaboration with the FujiNet. So basically, before I go live with FujiNet on my website, I also want to have a smart port card that I can have at the same time. So you can get both and do it. Flintlock 1, gotta sleep, guys. Good night, good luck. Thank you, Flintlock.
Flint, good night. Thank you for watching and staying up so late over there across the pond.
Yes. Enjoy your fish and chips tomorrow, or whatever random UK thing that isn't offensive. Have a nice evening. Tell the king I said hi or something. I don't know. Do a FujiNet, make it small, not like the actual one. Yeah, Javier. That's a really good question. The Apple II one, they're still developing. They're having a little bit of I don't know, an internal discussion about finalizing one tiny little feature with it that they're not quite sure how they want to do. Once that's done, then we can spin an actual final FujiNet board. What's available now is just a development and prototype board. So once that's finished, we can do that.
I have one hole that still has some solder in it.
Yeah, I hate it when that happens because it'll wick into the middle of the via and you can't get it out. So then you got to add absolute buttloads of solder to it to get contact with the wick and come back out sometimes. Of course, that doesn't always work either. It's the ones with the ground planes that tend to be the worst because they suck the heat out of your iron and you can't get at them.
Well, I might have just figured out why I can't install anything of any significance on my 386 computer.
Bad RAM?
No.
Bad hard drive?
No.
Bad Mojo?
No.
Bad IDE card or bad IO card?
Maybe. Because I'm having trouble. I was having trouble for some reason getting DOS 622 to install on the 486 with my Visa Local Bus controller. I kept getting random read errors off my GoTech. Tried a different GoTech. Tried just putting new DOS images straight downloaded from a reliable source on the GoTech thumb drive. Still would get read errors while it was trying to copy random files off the floppy drive. So I decided, well, fine, let me just put my 16-bit controller card in the 486 because that should just work.
Yeah.
And it won't even boot off the floppy drive. It looks like it just seeks to random sectors on the floppy drive or random tracks on the floppy drive, and then I get a non-system disk or disk error.
It's clear. I think.
Which really.
Yeah, Bob Darlington had a cool trick too. Heat the board and drop it an inch. Yeah, the smack method. Yeah, if you get it liquid, you can go, and it'll fall out. And it's an Apple III. It's going to need to be smacked 3 or 4 more times anyway. Drop 3 inches and such.
Okay. So I just put the Visa Local Bus controller card back in because, well, the 16-bit controller card works even worse in the computer.
I think when I was doing that work on my 386 a couple streams ago, and it just randomly failed, I have a feeling that my controller card in that is bad as well. That's not the original controller card I had in that. That's a different card that has a better, whatever you want to call it. It has in theory, a better floppy controller on it for doing disk preservation, but I don't need that anymore because I have an applesauce that will preserve everything forever. So yeah,
I just got an applesauce and I haven't done anything with it yet.
the applesauce is the bomb.
Well, this is
Bob
just
is saying clean off the flux. I'm sure he will clean off the flux before he turns the machine on.
Yeah, right now I just want to get the sockets going.
What's Zodium playing tonight?
Just once again trophy hunting in a game.
Before installing the sockets, why would you want to remove the flux before the sockets? Otherwise, because it snags the. Yeah, I get it. Bob says, Bob is it's a pet peeve of his. He's like, clean the flux off before you put the socket on, or else it'll snag and be a pain to clean up later with the socket.
Oh,
That's what he's saying. You don't want any of that goop on the board. Yeah, we'll get it off there. I am very aware of there. He's cleaning it for you. There you go, Bob. Hush.
Are you happy now? Are you not
Guys are
pleased?
addicted to that stuff. There's no need to add flux when soldering. I agree with you on that one, Bob. My solder has rosin flux in it, so I don't usually add flux when I'm soldering. I will only add flux when I'm doing SMD stuff or when I'm using it to clean pads or whatever. But it's under the socket.
okay. Now maybe that'll
What
work.
ultrasonic cleaners for?
Yeah, but I don't have one the size of an actually laundry sink. Okay.
Cool. Yeah, I'm a big fan of cleaning boards when I'm done. Not only because it's just nasty, but also I've seen in many cases the flux I use doesn't tend to do this, but I've seen in many cases the flux itself under, I don't know how to explain it, but it basically can turn joints into capacitors. It can do all types of weird capacitive coupling, electrolytic coupling between bins. I was working on a board for Javier once that he had somebody else work on him for him first, I think. And I was just getting weird, funky capacitance on data buses and just like, that's the best way I can describe it. I removed the socket, cleaned it, and put the socket back in, and it solved the problem. And the flux that was used smelled like Dawn dishwashing liquid. It was weird. It was the weirdest thing. So.
Okay, how many viewers we still got out there?
We're at 28. We've only gone down by.
Yeah, we're doing good.
Yeah, we're doing good. People just like to. These things are chill streams. People like to just listen to them in the background and kind of chill out and do their own thing. Adam McGee says, Bob, I dare you to solder a cheap knockoff blue pill to a blue SCSI without flux. It's impossible. Adam, I love you to death, but it's not impossible. I do it all the time.
Solder what and what?
Oh, Adam is saying, I dare you to solder a cheap knockoff blue pill to a blue SCSI without flux. It's impossible.
I do it without flux.
Yeah. The only time I ever use flux is for surface mount stuff. Because it helps you do drag soldering and stuff and keeps the solder from like bridging. It keeps the joints clean, and you just clean the flux off and you're after it. It just works for me.
Okay, I just tested those pins again, and it seems okay.
Okay, well
Where's my chip?
let's do the thing and see what happens. And if this doesn't work, I think we're going to be done for the night.
Yeah, because it's getting late for me too, almost 11.
Yes.
For everyone. Okay.
I think we wanted to see about just powering it up without the. Well, I mean, you could just throw the RAM board in it and see if it just works. Or we could try, powering it up without the memory board in it and see if our address.
Yeah, well, that's what I want to go see.
Lightweights. It's not even 9. It's almost 11 here, Bob.
It's only 7 over here.
Bob is out in like mountain time. He's out where it's neat and dry. I know where Bob is. I'm not going to tell any of you, but I know where Bob is because he ships.
All right, so, what am I looking for?
Let's just check pin 9 on the CPU.
Pin 9?
Yep, because we know that's an address line. You grounded?
Yeah, but I just gotta.
Fine. Okay.
I gotta get something first in the right setting, and then I can see it.
Because that's kind of it's an auto mode type of thing. Do we have wiggles?
No, but this is on pin number 3.
Okay.
Pin 2 is high. That's it. Same thing.
That is weird. Oh my god, that's weird.
I can try and this is the original 244. I can try a new one.
Yeah, go ahead. I don't think it's going to have any effect, but you might as well.
No, I don't think so either, but...
That is so... 244 is only inputs.
But could it be something else down the line somewhere instead of the 244? No, because there's nothing else. There's nothing else coming into the address lines, right? No.
Adam G said, are known working ROMs available? The pattern that was on the screen looks like what I see when a 2C has a faulty missing ROM. Adam, we've gone through all that earlier. The ROM he has is no good. We ran it through his tester.
This ROM is actually from my other Apple III that actually works.
Yeah. We also ran it through the tester, and it has the correct
checksum.
So we know that's not the problem. The thing is when we pull the 244 out, the CPU runs. If we put the 244 in, the CPU does not run. Like, it literally halts the CPU, even though the only thing that 244 is connected to are the lowest 8 address bits. How it halts the CPU, we have no idea. Yeah, just high.
There it is. It's high.
Adam, we've swapped the ROM and the CPU, both of them, in case you're curious. So.
Yeah, both of these that are in here now are from a working Apple III. The 2 that were originally in this machine are actually right here. Here's the CPU and the ROM that was originally on this board.
So weird. It is so weird. When we look at the schematic, I mean, we can look at it here real quick.
Well, I still think that tomorrow I'm going to change the socket for the ROM and the CPU, because the CPU is also one of those machine shop ones.
Yeah, the turn pin, machine pin. Yeah, I mean it's not going to hurt to do that. They're going to want to be done anyway. And the ROM, like you said, the ROM socket's loose. Even though when we pull the 244, we are getting signal from the CPU to the ROM socket. It's not going to hurt to replace that. Just because you're going to have to do it eventually anyway. Right. So, yeah, I don't know, man. I am hyper confused-a-doodle by that. It does not make any sense to me.
Yeah, because let's see if when I pull this again, let's see if it does the same thing still, and I'm sure it will.
So if there's anybody in here who knows why connecting this LS244, whether it's a brand new one or a non-brand new one, is original or a new one, knows why that would cause the CPU to halt.
Oh wait, I wanted to do it without. Okay, so here it is without.
Yeah, make sure you take the metal thing. Take the scared the crap out of me.
Huh?
You had your
The tweezers there, yeah.
tweezers on there. I'm like shorting things.
Well, I'm shorting things too, but that's the jumper that says.
Okay, you
short
see,
these-
there is 9.
Yeah,
There's
so
pin 9. Address 0.
and so without that in there, the CPU runs. And the moment you put any LS244 into that socket, the CPU halts. It just stops. And we can see this, and I'm just reviewing this for anybody who's listening. We see this by looking at, for example, the CPU sync line. The sync line should pulse at the beginning of a valid CPU instruction. And when we put it into 244, the sync line does not do anything. It just doesn't do anything. Like and then also we have the address lines, which don't do anything. It halts the CPU. But everything else that could halt the CPU doesn't do anything. NMI is high. NMI is high. Ready is high. IRQ is high. Reset is high. Those are the only other 4 things that would stop the CPU from running. What else? Adam's saying, what else is the 244 connected to? I mean, I can show you. I got the schematic right here, Adam. The 244 is right here. It connects to the input side of the 244 anyway. Connects to the ROM chip and the CPU, and that is it. That's all it connects to.
Yep.
Is the clock still happening? Reset isn't asserted, not that it should be affected by the 244. We checked all that several times, Tom, and those we found to be doing exactly what they should be doing.
Pin
Adam,
40, pin 40 is a reset, and that's high. Here
Yep.
you go. And 39, 38, 37 is the clock. And we're getting 102, which is what it should be.
mm-hmm.
So those are fine.
Pin 38 should be low. Is that correct? It should be
Yeah.
just touching the ground.
Yeah, low.
Yeah, okay. That's an output pin anyway. Yeah. Like, and pin 7 doesn't. Well, pin 7 should be doing something right now.
Jake is saying something that it had a battery pack, but that is for. I don't think a battery pack would have any interference right now.
Yeah, that's just for the real time clock. That's the second chip from the top left there. In theory, I think that would, yeah. My board doesn't even have the chip on there. Maybe the CPU expected WAI or something and is just waiting for an interrupt. This is a 6502B. It doesn't have the WAI instruction. That would require 65C02. Mm-hmm.
Oh, is there a?
I'm getting a text from my mom.
Hi, Mom.
My
Hi, Joe's mom.
viewers say hi. I'm on a live stream right now. Smile.
You see? Oh, they can't see my face. They can only see you, Justin.
Adam, does this board have an IOU or MMU like a 2E2C? No, Adam. It's all All of that stuff is done via just a bunch of logic chips. Time to get to work, night, everyone. Thanks for the stream, Joe and Will. Good luck, and we'll check the rest of the stream later. P.S. Make a nopper. Yep. Mm-hmm.
Yeah, as soon as I put that back in, it goes to high.
Yeah.
No matter what I do.
Yeah. Does the CPU not execute at all with the 244, or does it run a bit and then halt? That's a good question. In order to see that, we would have to, Will, you would have to put your you'd have to put your scope in like one-shot mode or single mode or capture mode or whatever you want to call it, and then turn the machine on and see what happens. Adam, yeah, I forgot to mention this before. Thank you, Adam, for yelling again. Will, Adam would like a link to that Lisa SCSI interface or whatever interface project.
Yeah, I'll send it on the actually Discord, Adam.
Cool.
There's actually two Eschi sites. There are two different people working on different projects, but they also work actually together. So one of them is a female, Lisa, I think. Well, no, not Lisa, but something Cat is her name.
Lisa, it's your birthday. Waiting so I don't get copyright strike.
All right, so I need to put this in the stop mode.
What's that?
I need to put this in the stop mode, single mode.
Yeah, just so when you turn it on, you can get some sort of idea if it's trying to execute stuff and then halting.
But on which
might be
pin?
Executing bad code. Yeah, Tom. Usually, the 6502, if it gets a bad instruction, unless it is faulting because of a undocumented instruction, which just causes a CPU to go. The 6502, when it executes a bad instruction, it will execute its break instruction handler, which is a FECD FFFA. Right. It's basically a software interrupt. And so if it's doing that, it'll do the thing. Can someone forward it to me? I'm not really on Discord right now. I understand, Adam.
Send me an email at CayMac Vintage, at Gmail, and I'll send it to you.
There you go. So yeah, like I was saying, the 6502. Yeah, I'm concerned about the undocumented ones. It could basically just kill everything on 6502. I mean, yeah, that's totally possible. That the ROM socket's just wacky and it's very consistently getting a bad instruction and holding the machine. Could be.
Yeah, I'm gonna change that socket, but I'll do that tomorrow because it's getting late and we've been on for a while already, but it's not that long. But you wanted me to check something about when turning it on, but which pin and which chip?
Just like one of the address pins or something, just to see if it looks like it's trying to execute something before it halts, or if it just immediately goes high no matter what. Phil L gave a good suggestion. You could try lifting one by one the output pins of the 244. May help narrow things down. That was an idea I had too. A little tricky to do and not break your 244, but if you got spare 244s, it really doesn't matter that much. Sodium, you're cheating. You can see where they go. Which is how I would have to play that. Yeah, there you go. You got a
You got a game hack.
Which is how I would have to play it because I can't. I need video games now.
Oh, 244. One of the input pins is 2. Yeah.
Yeah, the input puts are 2, 4, 6, 8, 11, 13, 15, 17. That's the input side, and the output side is the output side.
All right, well, 2.
Phil is saying to lift the output pins, but I would be lifting the input pins personally. It would disconnect you from RAM, kind of, but Jake Janowski, here's that link, or input, yeah. We're just trying to isolate those the 244 pins.
Yeah, but Jake, I don't think you can post links.
Yeah, Yeah, Jake, you cannot post links because you're not an admin. I'm sorry.
Okay, well, lifting 2 didn't make any difference.
Okay. So let's try 4. Let's try all of them until one of
Yeah,
them
but
makes.
it bring actually 2 back down or keep it up?
I would leave it up. What's the buzzing? Who's doing buzzing?
It sounds like someone's 3D printing.
Not me.
Is it really picking that up?
Yes.
That is Tetris being Tetris.
Oh, okay. Oh, is it picking up your shot controller?
No, it is. It's picking. The soundtrack is just really weird for this one. So,
By the way, Zodium, there you go.
Ooh, yes.
Silver filament to match your computer.
What is your confidence in those brackets?
The confidence in this bracket is relatively high. The confidence in this one is relatively low. I've already had to super glue it in 5 different places.
All right, Joe.
Yes.
Look, 2 and 4 are up, right?
Yeah.
2 and 4. That's address 0 and 1, right?
Yes.
Okay, pin 9 is actually 0. Look at the scope. So that's because it's lifted.
Huh?
Okay. Pin 10 is address line 1. It's lifted.
Yeah.
All right. 11 is not lifted, and look.
So it's pin 2 or 4 that's the problem, but you lifted 2 and it didn't fix it. Then you lifted 4 and it fixed it.
Yeah. So I can put 2 back down now.
Yeah, let's put 2 back down and see if it stays the way it is. And then that might isolate us to at least know whatever's on pin 4, 10.
Yeah, there might
whatever.
be a busted trace or something somewhere, or something that's
Yeah.
So I got to put 2 back down.
Mm-hmm. Naboo. Adam, I made that lights on my Naboo adapter work today. I ordered a Naboo adapter from that company in Nebraska or whatever that has them, just for giggles to have one. It doesn't have anything in it. It's just a box, but whatever. Adam, I now own the world's largest USB to DIN 5 serial adapter ever. That sounds like a challenge. Hold on. Hold my beer. I'm going to go buy a Vax.
Don't threaten him. He'll do it.
I'm getting signal.
So pin 4 is the problem.
10, 11, 12, 13, 14, 15, 16.
Okay.
Wow. Yep. Well, there you go. You got to trace that one out. We made progress tonight.
Yeah, but let's see something now.
I'm glad someone made progress.
That's not going to make that run because it's still not going to run code because it's missing one of the bits from the ROM to run code.
So pin 4, address line 1.
Yep. So it's a factor of figuring out why having anything attached to address line 1 halts the processor. Neat.
Yeah. Oh boy, where do I even start?
Yeah. I don't know. I think we should probably call it a night for tonight and come back to it and revisit it. Maybe we can revisit it again on your channel. But it's hard to, you don't have the live streaming stuff, so we'll see what we can figure out.
Yeah, we can do it on yours. That's fine. I mean, I can make a link to you.
Mm-hmm. I want to make sure people get views to your channel as well, because that's the whole point of this, is to, it's not, necessarily for me, but it's to show people, that you're awesome too. And
3 parts for Apple III. What do you mean? What do you mean, Jake?
Like part 1, part 2, part 3.
Oh, 3-part movies. Yeah.
Yeah.
3-part shows. Well.
Yeah, as long as we're the middle 3 movies and not the first 3 or the last 3 movies.
What I'm gonna do tomorrow, okay? Because again, I am retired. I'm home all day. Well, I can be if I want to, but anyway, I'm gonna try to see where all address one goes and try to trace everything and see,
Hmm.
Alright.
even if it goes through some capacity, through anything, because
Yeah. And
now
so,
we
see,
know.
here's the thing: is that we're going off the original Apple III schematic. For all we know, we've all been told that the 3 Plus is electrically this identical, but maybe it's not.
Yeah.
So, yeah.
Oh, Jake, do not remind me about that 7500 prototype you got coming to me. Oh boy, I know. You keep on sending me all of your prototypes and all of your difficult boards, but it's okay. It's fun. I like it.
Hey, I
Anyway,
mean, trial by fire, right?
yeah. Well, that's what I did. I mean, that's how I got his two actually VIs working. I mean, no one got them working. He sent them to me, and I fixed them. Oh, so how I really don't know, but anyway,
Brute force and ignorance,
yeah.
as Big Clive likes to say. Yeah, Dave
So
has also thrown an invite out to you on his Sunday stream that he always does. You can see that. Tom was asking when the machine was halted and locked up, what data was on the data bus? That's a really good question. Depending on where you probe it on the data bus, you're gonna get a different answer, because the data bus switches between the CPU having control and video having control. It goes back and forth. So yeah. So anywho, I think we're gonna call it a stream for tonight. We made some excellent progress, and we got this kind of narrowed down to something with address line 1.
yeah.
That's good. So I'd like to thank everybody for stopping by.
Yeah.
Who stopped by?
I'm gonna change these two sockets tomorrow too,
Yeah,
the
we're gonna,
CPU and the ROM,
and
and
for
see if
all
that
we know,
makes
you
sense.
could do that off camera and get it done.
Yeah, well,
Record
I'm gonna try that
it,
off. Yeah, well, I can record it and put it out there. Yeah, I
but
will I will do some recording tomorrow on it, and I'll take out those two sockets, clean them, check them, make sure everything is good. Because who knows? Maybe that address one is to the ROM is the problem, and then the ROM to the CPU. It might be sitting
yep.
right in there.
Yeah, and it's also possible, like Tom is saying, apparently when the what's called the kill instructions, the bad instructions in the 6502 execute, the data bus will be stuck at FF, and it might do that to the address bus too. It just goes and asserts everything, keeps it high, and it just breaks. So absolutely, totally possible there. So yeah. So yeah, bit 1 is just stuck on at all times because of some sort of funkiness to, or 1 or 0, or funkiness to that ROM socket. I guess that could cause that. So yeah, good things to check, get those ROM sockets done. So
Yeah, but that's the data bus. So then on the data bus, we shouldn't be seeing any signal then, right? We
maybe,
shouldn't be seeing any wiggly, because we
maybe,
are seeing that.
maybe. See, it depends on how the machine is designed and set up. The data bus is shared between the I/O side, or the computer side, and the video side.
Mm-hmm.
They alternate having access to the memory bus,
Mm-hmm.
and it runs at basically twice the clock speed. Because when the CPU is not accessing the video or accessing the memory, the video circuit is to fetch data out of memory to put to the screen.
Okay, so based on what you just said there, then could it be coming from that latch that actually switches back and forth between?
Like, could that be causing the problem?
Yes.
Unlikely. If that latch was messed up, your video would be screwy.
Okay.
If that latch was messed up, basically it'd either be stuck all the way over to video, all the way over to CPU, or it would be mixing the two, and you would either get nothing on the screen would be completely white or sparkly, or you would get just some other generic noise on the screen. You're not getting that. You're getting perfectly clear how can
Garbage.
we put it? The garbage is static.
Uh-huh.
It's not like twinkling and moving around, and it's
Yeah.
just, which means that the video side of the computer is getting access to the memory just fine.
Okay.
So yeah, I don't think it would be that latch. I mean, it could be, but I doubt it. The fact that we pull A1 and the CPU is suddenly like, oh, I work now. Yeah, no.
Mm-hmm. Okay, so I will basically follow. I'll try to follow A1 everywhere where it goes and see.
Sounds like a plan to me.
Nothing new to me. I've done that with actually classic boards and classic 2s, tracing every single line, so it's fine.
4 hours later.
Well, that's okay. I've got all day.
Yep. All right. Well, I'm going to call the stream tonight again. Thanks for Will, CayMac Vintage, for stopping by and giving us the chance to diagnose and work on an Apple III Plus tonight. It was super fun. Remember to go check out his channel, subscribe to his channel, watch his videos, like his videos. He's got tons of cool content, doing all types of things with Macs and Blue Scuzzies and all different types of things. So that's down there at the screen, down there.
At the bottom.
At the bottom, just at CayMac Vintage on YouTube is you can find him. Again, thank everybody for stopping by. While you're here, hit the like button. It helps out me. Subscribe to my channel if you're not subscribed.
Adam, make sure that you send me that email, please, so I can send you the link to
send him the
to
email.
get the boards.
And thank you to Justin and Zodium for coming on and being my comedic support and all of that. So
before we go, you need to give us an ad for JCM1.com.
Oh, that?
Yep.
JCM-1.com. Cool stuff for your old computers, including the Apple III.
Adam, one other thing too about those boards. I ordered 5. I'm not gonna need 5. If you want one of each, I can gladly send you one of each.
There you go. The community helping out the community.
So just actually cover the shipping. I don't care about the cost of it. That's fine. All right. So because I'm only gonna need 2 of them, because I did buy 2 actually Lisas. I got 2 actually for the price of 1, but one of them is gonna go to actually Jake. Jake is buying that one from me. So I only need 2 boards. I'm gonna have 3 of them left over. So you can have one of them, Adam.
Awesome. He says he sent you the email, so you guys can do the thing.
Yeah.
All right. Well, cool beans. Well, thanks everybody for stopping.
Thank you, everyone.
We'll check in later and see where we go.
Yeah, I'll probably post a video of some work that I do on it tomorrow, and we'll probably have another live stream. I'm not sure when yet, but we'll have another one on it. Okay. Cool. Thank you, everyone, for joining.
Good night, everybody. Thanks, guys.
Bye, everyone.
Good night.